Welcome to day 2 of the 2021 Moves Open House. Please enjoy watching this video. You may watch it in the order it's presented or jump to the video start time on the right. Thank you very much for your interest in the Moves Institute. Today is going to be dedicated to presentations by our students. I think you heard a lot of the faculty saying yesterday about how our students are really the backbone of Moves, and that's definitely the case. And today we're proud to showcase the work of several of our students who are finishing up right now. They'll be great. I think everybody today, I don't think Max is, sorry. But everybody but one of the students you're going to see today, two of the students today are going to be graduating in June. And so they're pretty much finished with their thesis work, except for, the writing and that kind of stuff. At least I hope most of them are pretty much done with that. But they'll be briefing us on that. Our first speaker today is Major Alex White. He's going to talk about the interoperability of network simulations for distributed fire support coordination training. And I'll stop sharing so Alex can grab the screen.
All right, thank you. And that should be up. I don't know if you can see those slides.
We can, yes.
Excellent. All right. As Perry said, thanks for the introduction. I'm Alex White, and this is a presentation on my thesis, Interoperability of Network Simulation Systems for Distributed Fire Support Coordination Training. The agenda will go through kind of some background, fire support coordination in the Marine Corps, current training systems and the shortfalls, and then walk through how we use the distributed simulation engineering and execution process to develop and implement a simulation environment to address some of the capability gaps. And close it out with some conclusions and recommendations. So fire support coordination in the Marine Corps, particularly from an infantry perspective, but this is generalizable to other perspectives. In general, up top, you've got observers, the company fire support team. They see the targets and they request fires. Kind of this middle row here, you've got our firing agencies, the shooters. They're the ones who put fires on target. And then in the bottom, you've got the approval authority, the ones that maintain really the big picture, situational awareness, understanding where friendly enemy units are, intel reporting, targeting data, making sure the fires that we conduct are safe, legal, effective in terms of efficiency and priority, getting the right asset firing on the right target. So between each of these agencies and the individuals performing their roles, you can see these lines are specific radio networks that they are talking on. And there's kind of a lot going on here, but hopefully you get a feel for the sense that each of these individuals has specific technical skills they need to develop. They've got whatever their role is, whether it's within the fist or identifying a target, getting the right grid, doing the correct weaponeering, making sure we're deconflicting by time and space and integrating and support a maneuver. They've got hard skills they've got to be good at, but they also, every single person on here is coordinating with an external agency to make sure the entire system works the way it's supposed to. And when it works well, very impressive, very effective, very responsive in blowing things up. It's pretty great. So to train to that, for the observers, as our example here, the Supporting Arms Virtual Trainer, or SAVT, is what we use. You can see here's our 4 members of the FIST, artillery, mortars, the JTAC, talking to air, and the FIST leader in that big wraparound screen, getting some, which provides some immersion. They can have some co-presence in that virtual environment. They've got instrumented optics, laser designator, target locators here, and comm tools so that they can employ all of those assets in support of maneuver. And this is a system that our JTACs are authorized to get a certain number of their qualification events done in simulation in this system. Very impressive, a great system for individual skills and that kind of team processing. The issue is, while they can work together to manage information, get their fire support plan together, executed and requested, and update as things change, all of them are talking and coordinating. All these other external agencies are controlled and played by a single contractor who's sitting over their shoulder and seeing everything they're seeing. So they very good technical skills training and team internal coordination, but the JTAC doesn't get the experience of talking to a real pilot who's going to be out supporting him in the future, who has only the perspective of a pilot in there. The SAVT operators have been very impressed with the ones I've worked with, but the experience is not the same. And that kind of highlights really the training shortfall. Fire support coordination, anything involving aviation is a attractive opportunity for simulation training. Same thing for fires, because the risk involved in operations, the availability of suitable ranges and aviation platforms, fires, and the cost involved, the more we can get good at this in sims before we go and execute live, the better. And so up top, you kind of see, hey, our high fidelity task-oriented simulations like the SAVT, like I talked about, you can get good at doing your job, but you're not talking to the people on the far end. The flight sims, very expensive, very impressive flight sims we use. Those are great for training pilots, but they can't interoperate with the SAVT and talk to a JTAC on the ground. We do have some C2-oriented sims, but in general, these are focused on training a battle staff or a coordination cell. And so in general, they provide inputs or injects to manage, to get the staff to work through communications procedures, information management, and decision-making. And a lot of times what that really ends up being is the inputs they're getting is a radio call from a guy who's pretending to be, an observer out on the hill, but really he's just reading a script. He's not assessing, making decisions, and really getting training value for himself. The Marine Corps' live virtual constructive training environment, down that last bullet, is kind of the solution intended to short-term bridge that gap by creating a persistent training network that integrates most of these systems, and we can do interoperable exercises using it, and eventually kind of later generations replace these legacy systems with systems that are built from the ground up for interoperability, and then add more kind of live training links, putting the L in LVC. So really the best the Marine Corps got right now. I'll start on the left here. The ADVTE, Aviation Distributed Virtual Training Environment, is the program of record owned by the Air Wing. It is a persistent, high-side classified network that all of our flight sims and at each of the Marine Corps Air Station simulation training sites are connected to, and each site has a network exercise control center where operators can really control the environment and provide the pilots what they need to get the simulation training qualifications they're supposed to get. And you can use the DVTE to connect either, hey, we want one Huey and one Cobra doing some H1 split section ops, or the example that I was able to get down there and see, very impressed by, 4 or 5 flight sims at Camp Pendleton, flying with 4 or 5 flight sims at Miramar, all in the same environment, all able to communicate between each other. Very impressive to me because it's way ahead of anything the ground side's got that I've seen on the ground side. But really the cool thing, relatively new, OASIS, the Operationally Adaptive Simulation Integration Space, new effort. This is a local solution. It is one-off, but hopefully it kind of paves the way for more integration of training. The 1MEF LVCTE team, huge thanks to those guys, Chris Getchell, Slade, Steve Mount, and Sean Sullivan for their hospitality and walking me through how this works. But they created a high side kind of local network here. We're able to install VBS3 and ASTI Voices on high side machines so that they could connect it through a disk bridge and integrate into the HLA Federation. So what they're able to do now is add TACP ground observers overlooking objective areas, overlooking landing zones, whatever you need, lasing targets for precision guided munitions. and they're able to work through the ASCII voices, the radio calls, talking to any of the pilots they need to on the simulated nets they need. But also there's a radio bridge that allows them to connect to live radios and integrate live radios into the entire exercise here. So real radio transmissions going out to a distant station, really starting to see some more of that L in the LVC, that live component. Very impressive stuff. So that's their local one-off solution to this training capability gap. For this, looking at really kind of replicating similar capabilities using unclassified systems and networks. And to do that, we followed the DSEEP, Distributed Simulation Engineering Execution Process. 7 steps outlined here, and we'll walk through that and how that kind of guided our creation and implementation of our simulation environment. So step 1, defining the objectives. We want to do a fire support coordination exercise. I won't read all those bullets to each of the things. I do want to highlight for the FIST, our ground observers, and the CAS platform, the close air support. We want some part task fidelity. They need to be able to observe the environment, make decisions, work through their technical skills to some degree, and really have separate perspective from the JTAC on the ground and the pilot in the air. So they have to be able to correlate targets, was something we were very interested in. Want to do distributed training if possible. Over the last year, the ability to continue operations, continue training without getting everybody in the same room became pretty clear why that's important. Doing it on class probably means a VPN. And then finally, the end state of this is demonstrating a proof of concept. This is not an analytic quantitative study. Really, can we develop a sim that we think face validity would support better training than the programmer record stuff that's currently available? So step 2 of the DSEEP is conceptual analysis. The bottom line is, what are we modeling? What are we trying to simulate here? So the real world, we stole a fire support coordination exercise event out of ITX, the Marine Corps' premier service level exercise, combined arms exercise, repeated multiple times a year in 29 Palms. So we're confident that it's tactically realistic, the right level of the complexity and training value. If we can implement this in our simulation environment, pretty confident that we're on the right track. We did, due to operator and simulation license availability, simplify. We've only got 1 indirect fire asset, the artillery, and 1 close air support asset, our rotary wing helicopters. Step 3, design the sim environment. As a baseline, we want to start out, we want to use DIS and applications that have native DIS support. We've got access to the NPS Argon VPN, which was established to support MOVE's education and research. And as much as possible, keep the cost low, utilize applications that are either already available within MOVE's or easily accessible. And so you can see, selecting the member applications, VBS4 for our ground perspective, FIST and maneuver forces, MACE controlling our constructive, artillery and threat, ground defense and air defense assets, and our pilot flying a helicopter in Lockheed Martin's prepared flight sim, and everybody talking using ASCII voices. So this was the kind of the original planned simulation environment. It's a little noisy, apologize for that, but each of these boxes here is a training audience member at their remote training site or kitchen table, what have you, running a blue simulation system and a green ASCII client. And you can kind of see what entities they're controlling, what roles they're playing in the sim. VPN in, connect to the ASCII server that's in the MOVE's lab, and the sim systems all coordinating their sim data using DIS broadcast. Step 4, developing the sim environment, the data exchange model. You can see here's our voice, our radio data exchange model. Who's playing, who needs to talk to who on which networks, allowing us to build that comm plan. Establishing the simulation environment agreements was pretty straightforward because DIS is pretty standard, and ASCII voices client server, we don't need to tell that how to work. Implementing the member application designs, in prepared. There's we got a rotary wing CAS platform on the runway at 29 Palms, perfect. Here in MACE, you can see up top of the picture, the enemy defensive positions in red, and then some friendly maneuver forces, constructive maneuver forces falling to the south, and our artillery battery. And then in VBS 4, we've got our observer up on the hill overlooking the objective here, and VBS 4 controlling a different set of constructive maneuver forces with their ground scheme maneuver there. With those, each member application having the scenario instantiated, moving on to checking the simulation environment infrastructure. If you're doing a field exercise, this can start as basic as, do we have tents? Do we have generators and power? For us, really, just making sure the Argonne VPN supported our requirements for DIS, which after a few months of back and forth and some troubleshooting, finally got the ITACs guys and VPN gurus at the virtual table and learned that UDP broadcast between VPN clients is technically impossible due to the routing information or lack thereof that's attached to each of those packets. It'll get into the VPN, but when it gets through that tunnel, unable to get forwarded to where it goes to get out to the other. So change of plans. We will run the simulations on the machines inside the Moves Lab on the local network there. Which is accessible via VPN, and distant users can use a remote desktop connection, and we'll see how well that works to get in. So here's the new simulation environment architecture. Again, inside the Moves Lab, centered here on this local network, each machine's running a simulation controlling its entities, ASCII client for radio roles, and then distant users can VPN in and assume control of that machine as needed. Step 5, integrating and testing the simulation environment. We followed O'Connor and Lesueur's recommended 7 activity blocks from their ITSIC LVC integration tutorial last year, which was very helpful in kind of a systemic process to get things working. I'll step through kind of some of the activity blocks here. The first one, network characterization. Bottom line, can you communicate between your systems? Can we ping each machine? Do we have the right ports open? Can we send data along the correct channels, such as DIS broadcast, PDUs, through the VPN? No. On the local network, yes. Once we can communicate between the machines, system simulation interoperability, is the communication, is the data that's being exchanged meaningful? Do we understand what's going on? Do the simulation systems, are they speaking the same language? So for these two kind of activity blocks, 2 of the tools we used, Mock Technologies DIS Spy was very useful. Any DIS packet PDU received, it would log it, and a bunch of different views. You could pull any information that's available to a simulation system. And this was much simpler than trying to use Wireshark to sniff for packets and then filter out DIS PDUs. And really, this is what allowed us to ensure we're not receiving PDUs on the VPN. We are receiving them on the local network. Now we can move from our network concerns to, if they're not showing up, this is an instantiation issue with the SIM system. And then on the right, you can see the VBS gateway. That might not be particularly readable, but VBS gateway is what VBS uses to incorporate DIS or HLA interoperability. And you can see here, this is a list of all the entities that are currently being represented in VBS. And you can see whether the first column, are they local? If they're remote, what's the DIS information? What's the exercise, the application, the entity tag for each unique entity? What's the CISO enumeration? What type of platform or life form is being transmitted here? And then what's the VBS object or model that we're associating with that enumeration? And you can tailor it. You can tweak it and say, hey, Mace is sending me this specific enumeration instead of what you're showing me now. Instead, I want to see this specific BMP with this anti-tank weapons capability. Incoming, outgoing, really it's what we use to make sure that a couple of the entities that weren't aligned between our 3 SIMs, we were able to configure it so that all 3 SIMs displayed the same entities, and we had they were all on the same page in the SIM environment. Moving on, really scenario thread and data collection testing. The key point here is if you want to test something, don't use every single system, every single operator, and run through the thing from start to finish. Identify what your key threads are, the things you're going to repeat, things that are critical to your simulation execution. Start there and then expand. So that kind of, code a little, test a little, that philosophy. Our critical threads were SEAD, the suppression moving air defense, and the closure series, each of which were integrating artillery fires with either close air support or maneuver. So kind of what that looks like on the right here, you can see VBS, our implementation of the closure series testing with the maneuver forces here, constructive artillery there. And then down bottom, MESA's call for fire interface, which very impressive, very intuitive in terms of translating a standard call for fire into effective constructive fires. So some of the issues we ran into down bottom there on the left, VBS4 performance. Up front, I don't know that this is a VBS4 problem. It could be a local implementation problem, configuration settings, but the bottom line, VBS4 performed very, very poorly in terms of frame rate and responsiveness on $5,000 top-of-the-line gaming rig that should not have had any issues. And we could not, by lowering, changing, adjusting the graphics settings, we could not get that to work suitably. In particular, every time an artillery volley detonated, which is every 30 seconds during a duration suppression mission, VBS4 would freeze up between 5 and 30 seconds. And for DIS, when it would freeze up, dead reckoning meant the other systems would see those maneuver forces continue to move steadily until VBS woke back up and they would snap back to where they were when it froze. And having that yo-yo effect really is going to break presence for a training audience. So workaround to that, maneuver forces were controlled in MACE instead of VBS4. Prepared, a very good flight sim is focused on pilot in the cockpit switchology, flight controls, and aircraft performance. It has some camera or sensor capability that's not great. It has weapons available, but those are all heavily abstracted. In addition, damage to ground entities, instead of VBS and MACE modeled damage on a scale from 0, completely destroyed, to 100, completely healthy, I guess. Prepared, 0 or 1. It was binary. And so what would happen sometimes, the pilot would shoot a BMP. It would be damaged, but display as being destroyed. And the pilot would move to another target, and that destroyed BMP and prepared would start moving and shooting at friendly forces. So really accepting abstraction for the close air support employment. Our workaround locally was the MACE operator, if he saw the pilot damaged a vehicle, would go ahead and just manually override, kill that entity very quickly to ensure we had a common operational picture. Remote desktop, we were concerned about some latency performance issues between visual feedback input to controls, but really we never got to that because we could not get the USB flight controls to pass through from the remote system into the machine in the Moves Lab running Prepared 3D. It seemed like there was a way to do that that required some significant kind of technical work that we could not get into. And then terrain. Each of these sim systems has its own method of generating terrain, its own database of what the terrain should look like. On the left, you've got a view from Prepared. On the right, the same perspective in VBS. You can see up top the macro terrain based on elevation data is generally consistent. You can see on that ridge line, that high peak circled in red kind of matches the overall flow of the terrain, and the shape of that ridge line is pretty consistent. You can use that as a key landmark, but the desert textures, the vegetation, very different. Down bottom, circled in red in each of these, there's a ZSU 23 TAC 4. The JTAC on the right in VBS is going to look at that big patch of vegetation, that peninsula extending out to the west, and use that as a visual reference point. If he tries to do that, the pilot flying in Prepared is going to have no idea what he's talking about. So kind of having the same perspective in different sims, using the environment for a talk-on was not particularly effective. So we used the effects of the artillery as a reference point, whether it was the detonation of HE rounds or purpose-employed smoke mark. And then finally, with our threads, some workarounds employed, ensuring we were getting the best we could for each of those threads, moving on to full scenario testing, going into our dry runs so that we could execute the simulation. Here's a local execution. On the left, Chris Cannon's running Mace as the artillery FDC, Chris Fitzpatrick putting on his DASC hat to role play the battalion Arrow and the FSC. And then Matt Gurister with the flight controls flying our close air support rotor. And then down bottom, you can see here's the perspective in VBS of the target area. You can kind of see pretty small this resolution, but our BMP, our targets here, our helicopter flying in, and some artillery effects all visualized. So step 7, analyzing the data and evaluating the results. Really, this is kind of subjective evaluation by the research team. Face validity is what we're going for. How suitable were our member applications? ASCII Voices worked extremely well. Really, the capabilities there far exceeded our requirements. Really, the only issues we had were the license that was available to us limited our number of participants. VBS4, impressive capability. We were excited about using it, but the performance could not get the performance to acceptable levels. Prepared for the flight sim. Again, as long as you're willing to accept that this is not a close air support training tool and accept the abstraction in some of the weapons and sensor employment and damage modeling, you can get flight performance, you can get the coordination, the timing and sequencing, the integration of close air support into the fires, which we thought was good enough. And Mace definitely impressed us with both the capability and the operability, intuitive ease of operation. Simulation environment itself, DIS worked very well, pretty painless, other than ensuring synchronization of enumeration for some entities between all of our systems, but it did not work through the Argonne VPN. Timing, DIS runs in real time. The time is always now. So we had to use wall clock time and do some watch synchronization, which wasn't bad, but really just kind of limited some of the time on target fire scheduling capabilities in Mace. And then the terrain, I've already discussed the shortfalls there. So simulation environment objectives, I'll move through this pretty quick and try and get to some time for questions. But this bottom line, throughout the thesis process, one column at a time, we added, working through here, starting with what's the role, their broad training objective, what are the components that the sim environments provide. Can we make that into some technical requirements to pick the right member application? And then at the end of it, the evaluation, each line is tied specifically to the component requirements. I may throw that up if we've got some time after questions, but conclusions at the end of the day, the simulation environment is not perfect, but in terms of meeting our objectives and providing a simulation training environment that doesn't exist outside of OASIS right now, we thought it met the objectives. If someone wanted to repeat this for training, we'd recommend, if you've got access to program of record simulations, VBS3 for performance, actual flight simulators for better close air support modeling. Go for it. Bottom line, if you can get into OASIS or recreate OASIS, talk to the 1MEF LVCTE team. Absolutely the place to start. If you can synchronize the terrain in some manner to get better environmental talk-ons, highly recommended. If you can do it on a local network, that will work better. If you have to do it remote, consider a different architecture, HLA or a multi-architecture federation, which would be a lot more work, which makes it a pretty good target for future thesis work, along with integration of naval surface fires. I think C2 system interoperability would be really huge, particularly in terms of moving towards more live in the live virtual constructive concept. C2 PC should be able to integrate for C2 requirements, FATIDs for artillery fires in particular, and then kill switch using a real world tool in the simulation environment to improve your a trainees' situational awareness and add additional communication coordination capabilities, I think would be awesome. And then finally, if there are studies involving training effectiveness, or I know Sharon Rundy is looking at cognitive assistance in the Fire Support Coordination Center. This, as a simulated training environment, short of going out and doing live fire, might be able to be an environment for any of those studies. With that, that is all I've got. I will throw this up just kind of in the background and turn it over if there are any questions.
Excellent, great. Thanks, Alex. That was a really impressive presentation. There were 2 comments in the chat, both by Fuzzy Wells. The second one is he's making a plug for his dissertation work because basically he looked at ways to get away from terrain inconsistencies, put vegetation down there that would actually match. So, he's plugging himself there, which is awesome. But he had a question there. His first one was, did you reach out to Bohemia about the VBS freezing issues?
So, and short answer, no. Trying to find what was available on the support. Did not reach out directly, really due to timing, running out of time, getting the thesis process done. But definitely worth doing to find out whether or not VBS 4 is worth pursuing or not investing in. I think that makes sense. And then I'd be interested to look into genetics, because I think there's a couple of the bottom line is a central terrain database that is implemented consistently in the manner each local sim needs makes sense. How to do that and really who's going to say this is the way. Interested in read more about genetics, but I'll take a look into that.
Excellent, good. John Richardson of Nywick asks, do the researchers submit to general simulation conferences? And I'll answer the general question first. And then I'll let you talk about whether you're submitting this research anywhere. John, we submit to a lot of different places, and that's really up to the thesis advisor for each thesis student to determine whether or not they're going to submit it. I'd say probably the place where our thesis work is published most often is ITSIC, the Inter-Service Industry Simulation and Education Conference. I think we mentioned that yesterday. It's in Orlando the week after Thanksgiving every year. That's kind of the biggest place that we submit. But if you have any ideas on where we should submit, especially for a particular piece of work, please let us know. And Alex, are you working with Chris or to submit this somewhere?
Right now, we're working on submitting it to the thesis processing office, but I'm not closing the door on summarizing this in a different form and submitting it somewhere else.
Excellent.
All right. If there's no other questions, we'll stop the share and appreciate your time, gentlemen and ladies.
Great. Thank you very much, Alex. Really appreciate it. That was great. Okay. Our next presenter is Kyle Britt, and Kyle he's a captain in the Marine Corps, and he's going to be speaking on a game that he created for non-combatant evacuation procedures to train those up. It's something we don't do very often, but when we do it, it needs to be done well, and there's generally not a whole lot of time to practice it. So Kyle, thank you very much for presenting today.
All right, can everyone see the screen?
Yes, we're good.
All right, everyone can hear me. Okay, yeah, so I'll get into this. So good morning, ladies and gentlemen. Thank you for being here. I'm Captain Britt, and today we're going to be discussing my thesis work, which is entitled Operation Swift Withdrawal, a non-combatant evacuation operations war game. Whoa, there we go. So here's our agenda. We'll start by discussing the problem space, why it's important. Then we'll transition to discussing past research that helped me develop the approach to solving the problem, educational wargaming, my wargame design, the experiment I conducted, the results, future work, and lastly, we'll talk about the so what or implications of my research. So here's a problem space. First, to understand the significance of my research, we must all gain a collective understanding of what a NEO is. So according to the Joint Pub 3TAC68, which is the NEO publication, non-combatant evacuation operations are conducted to assist the Department of State and evacuating non-combatants, non-essential military personnel, selected host nation citizens, and third country nationals whose lives are in danger from locations in the host foreign nation to an appropriate safe haven and or the United States. Although the current methods of conducting this training is adequate that the Marine Corps has, I believe there are some areas that we can improve on. I say this because I speak from experience, because as a lieutenant, I actually trained for this to conduct this mission. Although I received some really good training, I walked away from the experience reflecting on how I can make the experience better. And the education I've received thus far at NPS put me in a position to be able to provide a solution to make the training and experience better. Therefore, there's 3 areas that makes NEOs interesting subjects to study, and those are listed here. One is the NEO mission rehearsals. It requires them to integrate a whole bunch of capabilities, government, non-government capabilities, and a lot of that costs a lot of money. And yeah, it's just hard to actually train it, put these units together, actually train it. MUs, or the units that are attached to conduct this, they only receive at most 3 opportunities to conduct the mission as an aggregate unit. The individual units that are under the MU that actually conduct the mission, they conduct training on their own, but to do as an aggregate unit, it costs a lot of money and it takes a lot of time. And that's the reason why they only get at most 3 opportunities to train to that mission before they deploy. Current mission rehearsals are canned. I say canned because they're standardized training events, and it's just very standardized. So there's really no movement or no room for flexing, so that flexibility, so that they can get different training scenarios. And because of that, the MU would benefit immensely from a system that provides this additional training repetitions without predictable scenarios. So why is this important? Well, it's important because Commandant's planning guidance has stated that increased reliance on wargaming will be required to develop the critical thinkers to develop some of the strategies that we need to employ in the future operating environment. That being said, as the Marine Corps moves forward, they're going to place a lot of emphasis and a lot of support on wargaming. That being said, we just stood up the Wargaming Center in Quantico, where I'll be going for my next duty stage. So that means the Marine Corps has a very big stake in wargaming. The NEO is actually the MU Corps Met, meaning that the MU is trained for this mission. They're expected to execute this mission at a moment's notice. The NEO skill atrophy is a concern because, like I just briefed, the infrequency of training and the passive methods of delivery. I say passive because some of the training is delivered via PowerPoint presentations. And like I said, the infrequency of the training is largely due just to the time and of resources and timing. So what is wargaming? So over the years, the definition of wargaming has took on so many meanings and definitions that it kind of distracts. I believe that it distracts from their utility. Here are how the leading wargame advocates define wargames. So if you look at the top one, Peter Perley, he says an exercise in human interaction. Dunnigan, he says, is basically glorified chess. We have Sabine, who says that it's military simulation games. You have Applegate that says a dynamic representation of conflict or competition in a synthetic environment. So I took all of these definitions and kind of made a very simple sentence or definition that I go by that kind of combines all of their definitions. And what I believe a war game is any simulation of contention that combines players, decisions, and consequences in a synthetic environment. So now that we all have a good understanding of what wargaming is, I would like to discuss the benefits of wargaming. To do so, we got to go back in history and leverage the work of Linwin, Dewey, and Paget, as well as Kolb. Essentially, all of their work points to the idea that experience is a gateway to learning and retaining knowledge. David Kolb, he actually expanded on the works of the 3 other gentlemen and developed what he called the experiential learning cycle. This model is actually depicted at the bottom of this slide that you see there. So according to Kolb, traversing repeatedly through all 4 stages of this model is required for effective learning to occur. That is, a person has to engage in new experiences. They have to actively engage in experience reflecting, They have developed sound theories about their reflections. They have to use their theories as a basis for the future experimentation. I believe it's an interesting fact that because wargaming provides the perfect platform to traverse through all four stages of his experiential learning cycle. So moving on to Klein. So what Klein did, he did a fire team commander study, and he proved that expert decision makers do not make decisions by conducting exhaustive analysis of alternatives to come up with optimal decisions. What they actually do is they pick up on cues within the environment that leads them to single decisions that most often is the best decision given the scenario. I believe this is important because proper wargame design can help individuals develop the necessary skills to build their repository of experiences and pick up on environmental cues that will lead to better and faster decision making and leverage their experience in real life scenarios. Another research is Ebbinghaus and his research on overtraining and overlearning and how that leads to increased retention of tasks. I think this is important since players can play war games as many times as they can. It's actually limitless. And wargaming also provides that platform for training that leads to longer skill retention, which gets at the issue that I described earlier about neo skill atrophy. Lastly, these are the thoughts of the wargame advocates. Of note, they believe the benefits of wargaming is an aid to education, lessons and experience that can be leveraged when organizations actually go to war. It provides a decision-making environment. It imparts new knowledge or provide valuable experiences. Now that we know what the benefits of wargaming are, here are some questions that guided my research. So at first I had to figure out at what level do I want to have this education wargame that I built? And I decided to have it at the tactical level. Next, I wanted to decide the learning objectives that I actually wanted to reinforce within a war game. When I was looking at the NEO training, I didn't find anything specific that stood out to me. So what I decided to do was read the joint pub, and the joint pub states that there's three NEO guiding principles, which are accuracy, security, and speed. And that's the learning objectives that I actually want to reinforce in the war game. The leading wargame advocates believe that history and research is a great point of wargaming. And if you don't do that, then your war game is really not that good. So what I did was I did research and I came up with a historical NEO that I would like to base my war game off of. And that was a 2006 Lebanon NEO. The reason why I chose that was because it was the most available information on that event regard to the number of people that were evacuated, as well as the number of assets that were used. So I was able to get a lot of information about that specific NEO so that I could accurately model that NEO in a war game. And lastly, my research question is, can the NEO guiding principle be modeled and presented in the form of an educational board war game that provides an ECC team additional training repetitions and augments the current passive learning and standardized scenario training methods? So right here, Peter Perler actually, from my opinion, he actually gives the best advice with regard to NEO war game design to help war game designers actually conceptualize how you actually build war games. And what he says is that all good war games encompasses these elements right here, which are objective scenarios, database, models, rules, players, and player phasing and war game phases, as well as game mechanics. So right now, what I'll do is I'll discuss each one of these in the context of the war game that I created. So game mechanics develop player patterns of behavior, but the game objectives are the goals that the players achieve by demonstrating those patterns of behavior. Therefore, a well-designed war game can reinforce learning objectives through carefully designed mechanics. However, the overall objective of this war game that I created for this thesis was basically to evacuate all of the evacuees that show up at the ECC in 6 game turns. Each game turn in my war game represents 1 full day of operation. So a lot of effort is placed into writing game scenarios because that actually puts players in the positions and helps them feel as they were actually in the position of the people that they're representing in the war game, so they can actually make the same decisions that those individuals will actually make in a real life scenario. So here's the war game scenario for my war game. So basically what happens is you have the a MEU that's sitting off the coast of Lebanon. And what happens is that there's a coup d'etat that's going on in Lebanon, and it's resulted in a massive loss of life amongst Lebanese and American citizens. Because of that, the ambassador has requested an evacuation of all the American citizens, as well as other designated evacuees. The request went up and the request was approved, and Department of State, they have an F-77 report. This report is a report that contains the estimate of the number of American citizens and other designated evacuees in the country. They give it to the MEU, and the MEU believes, based off this report, that there's 3,600 evacuees that need to be evacuated. However, due to past evacuations, that number is sometimes is underestimated, sometimes it's overestimated. So that's the scenario for the war game. Also, Perla, what he says is, now we're moving on to database. From a database perspective, what Perla says, the database of the game contains the quantitative information about capabilities of forces and logistics. So this war game contains simple units. So basically, it's a company of USMC infantry. It has an ECC platoon, Evacuation Control Center platoon. It has 3 ships, RMU ships that will help with the evacuation. It also has 3 CH-53s to help, LCACs, as well as merchant vessels to actually help with the evacuation. So models actually translate the data and the decisions into the game, into actual game events. So what I did was, for this war game, I borrowed 2 models from previous work that was done with ECCs and via discrete event simulation. And I actually use simple mathematical models. So the first model that I borrowed was a model that was done in the past. It was about the optimal number of people within the ECC teams. So the ECC team is broken up into a 19-man workforce, and it's broken up into 4 different teams, that 19-man workforce. And then what happens is, based off of how you assign those teams, that dictates the how many number of evacuees are able to process. So what I did was I took the information from that model that they ran in that research, and I used it and I tweaked it to something that I could use for my war game. So what that came out to be is that a 19-man workforce that works for 12 hours can process up to 700 evacuees. If they do 18 hours of processing operations, they can do 1,000. If they do 24 hours, they can do 1,400 evacuees. Also, I incorporated the variability that's associated with evacuees arriving to the evacuation site. So previous work did discrete event simulation to model the mad rush, the wait and see, and the people that actually arrived to the ECC site at the last minute, based off of when the warning system gives a warning that there's an evacuation. So I also use those models in my war game as well. And the last models that I used were basic mathematical models that calculated the capacity of the transportation assets, as well as the transit times between different locations in the country. So war game rules. So here's the war games rules there. Very simple rules. There's not many of them at all. They range from the different locations that the 53s can actually fly. They only fly to specific airports in a war game, as well as the situation updates. Those situation updates are only last for that specific turn that the update applies to, as well as a simulation of when the evacuees are evacuated to a specific site. They have to wait an additional turn in order to be considered evacuated, to actually simulate the movement from a port to an actual airport to fly out of the hostile country. Next are the players. So this war game only has 2 players, which is the ECC commander as well as the security team leader. So both these players actually work together to achieve that the war game objective of evacuating the American citizens or the designatees in the war game. So they work together throughout the game, and they just play the game, and they assist each other in the best strategy to actually meet the war game objectives. So playing the war game. So basically what this war game does is it has repeated patterns of behavior. And those repeated patterns of behavior is establishing security, establishing the evacuation control center, and processing the evacuees, and then responding to any environmental changes. So basically how the war game works is it's broken up into 3 different phases. So first, the game setup, the players, they gather all the counters, and what they do is they establish the ECC in the vicinity of Lebanon. And from there, they transition to the ECC phase. That phase corresponds with the guiding principle of speed. At that point, what they have to do is they have to simulate processing the evacuees and preparing them for the evacuation out of the country. After they do the processing, the processing operations, they transition to the movement phase. That phase corresponds to the guiding principle of accuracy and security. During the movement phase, they'll actually move the transport the evacuees from the evacuation control site to their next logistics node, or whether that's a port or airport, to actually fly out of the country. Then lastly, after the movement phase, each phase will have a situation update. Those situation updates range from being provided extra sortie to the airport being closed due to terrorist activity, or the ports being closed due to changing sea states. So war game mechanics. So here's Board Game Geeks actually came out with a list of board game mechanics. And after looking at their list and comparing what they had on their list to the different mechanics that I had in my war game, I came up with these different mechanics. So what it says, core mechanics create the patterns of repeated behavior that which are the experiential building blocks of the play of the war game. So this war game encompasses dice rolling. It's a cooperative game, pick up and deliver, whereas the players, they pick up the evacuees from one location and deliver them to another location. Once per game, that's another mechanic, whereas in a war game, the players are able to use transportation assets once. That one transportation asset is the merchant vessel. So merchant vessels are in support of the operation. So if the players actually get to use that that asset, they're only able to use that asset once per game. And then once again, resource movement. For the players to actually evacuate the American cities, they actually have to expend their transportation assets to move them from one place to another. So after developing the war game, I transitioned into the experimental phase. So this experiment was conducted to ascertain as to whether an educational war game can be modeled, a NEO can be modeled in the form of an educational war game and reinforce those 3 learning objectives that I mentioned previously. So playtesting took place during January and April of this year. Recruiting execution took place in April. So my subjects were 20 active duty Marine officers here at MPS, and they were randomly selected from a population of 200 Marines. They included various MOSs such as logistics, infantry, artillery, and communications. And it was the 20 subjects consist of 18 captains and 2 majors. So what happened was, for this experiment, the subjects, what they did was they took a pregame questionnaire. That pregame questionnaire consisted of 11 questions about ECC operations that specifically ties to those 3 learning objectives. After they took that pregame questionnaire, they were given a cheat sheet as well as a war game brief and a demonstration of how the war game actually, the mechanics. And then after that, they actually played the war game. And then after they played the war game, they took a post-game questionnaire. And those questions on the post-game questionnaire was the exact same questions as the pregame. just so I could test their level of knowledge of NEO operations after participating in the war game. So here's the histograms of the pregame scores and the postgame scores. As you can see in the histogram for the pregame scores, the vast majority of the subjects scored a score of 3 out of 11. And if you look at the histogram of the postgame questionnaire scores, the vast majority of the subjects scored a score of 6 out of 11. So that's an improvement. So here's a graph of the questionnaire scores by subject. So all the 20 subjects and their pre and their post-game questionnaire scores. So if you look here, there's a couple of trends here. The first trend is that there are some subjects that did not improve at all. They scored the exact same on their pre and post-game questionnaires, such as in subject number 4 and subject number 9. Another thing that's interesting about this is that one subject actually scored lower on his post-game questionnaire than his pre-game questionnaire, which was subject number 15. And then I would like to direct your attention to subject number 11. Subject number 11 had the greatest improvement out of all of the subjects on the questionnaires. And what was interesting about this subject is that this subject disclosed that they had no prior knowledge of non-combatant evacuation operations prior to the experiment. So I thought that was really interesting that they had the highest score, improvement in score, and they had no previous experience with NEOs, whereas some of these other subjects did. So here's another graph of the questionnaire score. So here you can see the pre-game score as opposed the post-game score, as well as the difference. As you can see, the vast majority of these subjects, they all had differences in their scores. There was only a few that didn't improve at all. So actually, to ascertain whether there was actually a difference in the pre and post game score, what I did was I conducted a two-tailed paired t-test. So my null hypothesis was that there was no difference in the pre and post scores, and my alternative hypothesis was that there was. So if you can look at this, this is a graph from JUMP. So I can have confidence that I can reject the null hypothesis that there is a difference in pre and post game scores because this shows the difference between the post game score and the pre game score. So if you look at it at 0, those are the subjects that I said that didn't that showed no improvement in their post game score. And then if you see all the other subjects, except for that one subject that I said that that answered one question incorrectly on the post-game score, then his pre-game score is there as well. As you can see, all the other subjects, their scores are well above that 0, which the 0 is no difference whatsoever. So I have confidence that I can reject the null hypothesis that there is a difference in test scores after interacting with the war game. So the conclusion. So the conclusion of the experiment is that yes, that the guiding principles of NEOs can be modeled and presented in the form of an educational war game and actually reinforce those learning objectives based off the data collected from the 10 iterations of the war game. Like I said, the pregame questionnaire scores demonstrated overall modest comprehension of the guiding principles, but 15 out of the 20 subjects demonstrated a significant improvement on their post-game questionnaire scores, which leads to the conclusion that it does. You can model the guiding principles, and it does, playing the war game does help subjects learn about NEOs as well as those guiding principles. So some future work. So for future work, some things we could do is add additional models. And one model that I was thinking about was trust and evacuation team. So what usually happens is there's distrust among the evacuees of the the evacuees for the evacuee team, if they perceive that the evacuee team is not evacuating evacuees fast enough. So create a model that that incorporates that into the security, so that the security units have to think and make more decisions. That would be actually that would good. That would add a little bit more fidelity to the war game. Another thing is the time delays due to ID issues. One of the issues of non-combatant evacuation operations is once you get to the ECC site, you actually have to provide a means of identifying who you are, whether that's a birth certificate or a driver's license. A lot of times, if there's actual scenarios where people don't have that information or they don't have access to the information because there's unrest in the country, that causes a lot of time delays in processing when it comes to processing the evacuees. So applying a model like that to the war game will add more fidelity to the war game as well. So another thing could be additional game rule, designating transportation assets for certain priorities of evacuation. So the war game has 3 different priorities of evacuation, which are American citizens, non-American family members of American citizens, and then third country nationals or other designated evacuees. So designating that all American citizens have to be evacuated via aircraft. That's another additional game rule that could add a little bit more fidelity to the game as well. So that could develop a game rule like that. And then additional information on the ECC cards that the players draw. So right now, how they find out about the number of evacuees is they draw a card, and that card tells you the number of evacuees as well as their priority of evacuation, whether it's 1, 2, or 3. What I would like to see in future work would be health information. So whether due to that civil unrest, if the evacuee is experiencing life or death health issues, how does that affect the decision calculus or the decision-making process of the players as they decide how to evacuate them from the country? So, lastly, I would like to talk about the implications. So, I think there are some good implications of this research. So, one is that creating civil war games has the power of educating and reinforcing training objectives that cannot be conducted due to fiscal constraints. Another thing is that the actually participating in war game design actually creates better thinkers and military planners. I strongly believe this because the amount of time and effort and research that you have to do to actually correctly model the NEO process is a lot of time and effort and a lot of research that goes into that, and it ultimately makes you a better planner and be able to actually represent military operations and plan a lot better. So playing war games that are tied to specific learning objective actually helps players develop their repository of experiences that they can leverage in future situations where they have to make rapid decisions. Next, I also believe that since war games are conducted in synthetic environments, the level of player exposure is limitless. I think this is crucial because now that we're transitioning to different future operating concepts, it's kind of hard for people to conceptualize them, how they work, what is the point of them, what is the intent. And what we could do is we could use war games, specifically analog war games or board games, to actually model those concepts, and that will actually better educate the force about those different concepts. And lastly, I would say that war games provide players the opportunity to develop mental models about the consequences of their actions and their decisions, a platform to experiment with those models, and enough variability so that no 2 iterations of a war game is the exact same. I think that's very important because 2 of the subjects that participated in my study, they actually called me a week after participating in the study and were asking me different things about the war game, saying, hey, I've been thinking about this. What if I would have done this? Or what if I would have done that? I think I could have achieved the war game's objectives. I think that's really good because playing that war game actually got them thinking. And we start thinking about the consequences of your actions and the decisions that you make, as well as develop mental models about how you could have done it differently. I think that is the key to learning, and that's how you learn. So I think that's really good, and that's a great implication of applying war games to military operations. And lastly, here's what the board game looked like in Tabletopia. So I would say due to the restrictions on person-person contact due to COVID-19, playing this game in an online platform as Tabletopia was very crucial to me getting this research completed. If it wasn't a platform like this, I don't think I would have been able to finish in enough time. But yeah, this is the platform, and this is how we were able to conduct all 20 iterations of the war game. And with that, that's all I have. Are there any questions?
Excellent. Good job, Kyle. That was a great presentation about some interesting work. There's one question already in the comment section from John Richardson of NIWIC, and he asks, what about non-cooperative game aspects?
So non-cooperative game, I didn't actually model any of that in this war game because I was focused on the target audience was the ECC commander and the security team leader working together to develop strategies to meet those war game objectives. So I didn't really focus on that much in this war game.
Okay, excellent. And does anybody else have any questions? I guess I'll throw out one more is, during your play testing, how radically did the game shift from your original design to the design you used for the final testing?
Oh, that's a great question. So play testing was conducted by myself and Stefan. And, he's a war game enthusiast, and he was able to give me a lot of good information on how to make the game better. And one of his recommendations was to increase the variability of the events in the game by adding more evacuation cards as well as different situation updates. Because before, the original game design was all bad situation updates, such as bad sea state, you lose a sortie, or the airport is closed. So he, based off our conversation, I was able to add more variability with good situation updates, such as more sorties, as well as the inclusion of the merchant vessel to help with the evacuating the American citizens.
Excellent, great, thank you. Does anybody else have any other questions? Okay, well, thank you very much, Kyle. Really appreciate it.
All right, there's one more in the chat.
Oh, there is. Sorry, I didn't notice that. Yeah, Kurt, Reynolds, student from the junior cohort, popped up and asked, what was the most significant hurdle in the research process for this project?
So I would have to say that finding the information, doing the historical research so that you could properly model whatever NEO you're basing your war game off of. Like I said, I'd use the 2006 Lebanon NEO because that was the only NEO that I was able to find the historical data on so that I could model it correctly within the war game. So if you choose to do research like this, make sure you choose an event, a NEO, that you can get the information so you can model it correctly.
Great, Kyle, thank you.
I'm Captain Christopher Cannon, and my thesis partner is Major Stefan Gurka of the German Armed Forces. And our topic was using convolutional neural networks to develop robust combat behaviors through reinforcement learning. We were advised by Dr. Chris Darkin, and our second reader was Major Sean Clement of Track Monterey. This is the overview of the presentation that we will be providing today. And in recent years, there has been several headlining successes where deep reinforcement learning was used to develop agents capable of achieving above human performance in real-time strategy games such as StarCraft and Dota 2. These successes gained a lot of attention of several military researchers in the Department of Defense, as real-time strategy games have a lot of similarities with constructed simulations. For instance, they both require that the player create a strategy at the start of the game, and they must decide how exactly they want to employ their forces. During the gameplay itself, at any given moment, there could be upwards of 10,000 possible actions that a player is able to take in both constructed simulations as well as real-time strategy games. So using the understanding of the similarities between the two, in 2020, Captain John Boron looked to incorporate similar approaches in very simple constructive simulations. Using a MLP feed-forward neural network structure, John was able to develop agents capable of performing optimal massing and economy of force behaviors in 3 separate scenarios inside of his constructive simulation. Doing this, he effectively laid the groundwork for future military research, which brings us to our research questions that we use for our thesis. So we were looking to use, like John used an MLP neural network structure. So we look to use a convolutional neural network structure, which is specifically known for having spatial invariance when applied to imagery and we look to reproduce the simple scenarios achieved by Boron. Then after that, we additionally look to increase the complexity of those simple scenarios by introducing moving enemies, as well as introducing multiple set of positions. Then for following scenarios, we look to increase the complexity further by increasing the number of units, the types of units, and types of terrain. Then lastly, we wanted to see if a multi-agent training curriculum that was used similar to train a similar approach used to train AlphaStar can be applied to develop opposing agents in constructive simulations that can exploit each other's behaviors through competition. So now I'll turn it over to Stefan to go over the training environment that we use called Ella.
So for the whole thesis, we used an AI training framework called ATLETL that was developed by Professor Darton for scientific and educative purposes within the last year. It implements a server functionality and a Klein functionality for human user and AI clients. And in terms of the communication structure, it is a client-server structure using JSON for the communication or as communication protocol. For the implementation of the main parts, Python was used, and for the human interface, the graphical interface, JavaScript was used. Stable Baselines 3 was used as a reinforcement learning framework, and the whole model implements a simple deterministic combat model. Next slide, please. At the current state, ATLETL implements 4 different unit types that you can see in the upper right. That's infantry, mech infantry, armor, artillery. It implements 5 different terrain types and gives player the possibility to build up own scenarios and defining the setup hexes for the blue player and the red player. According to the movement, the movement values of the different units are implemented in a table. Let's say we have an infantry unit entering a clear terrain. If you take a look on the left table, you see 100. That means 100% of the turn is used to do this move. If we have an armor unit entering a clear terrain type, you see the value 50, which means 50% of the turn is used to do this move. That means if an armor unit would move into a second clear terrain in this turn, that would be possible. Next slide. The combat model, I already said it, it's a deterministic combat model. The attrition or the hit points an attacking unit inflicts on the attacked unit depends on the attacker's strength, the firepower, the defense bonus, and the scaling factor. The firepower, if you take a look on the upper left table, depends on the attacker's, the shooter unit type, and the target unit type. For an infantry unit attacking an infantry unit, the factor is 1. For an armor unit attacking an infantry unit, the factor is 0.5. The defender bonus depends on the target type and the terrain the target is in. Let's say we have an infantry unit in clear terrain, the factor is 1. For an infantry unit in rough terrain, the factor is 0.5. And the scaling factor is by default 0.5. The whole values can be easily changed in Python. However, we, for our thesis, worked with this default values for the whole time. Okay, next slide. If we take a look on the input structure and the action space of the neural network or of the infrastructure, then by default, the neural network is provided with 3 different inputs. That's the position of the acting unit, so the unit that Janet is right at the moment, the position of all blue units, and the position of all red units. On the right side, you see an example of a possible battle space, battle setup. In the middle, you see the 3 different input layers, all represented in a matrix. What you have to do now to get from the real battle space to the matrix is you have to shift the battle space 90 degrees to the left. And then another fact here is that to go from the battle space to the input representation, we had to work with double coordinates. That's because the neural network structure we used, the CNN structure, works with rectangle filter structure, while in the battle space, we have a hexagonal shaped battle space. So we had to add on the rows, like every second row, we had to add another row to deal with that problem. For the output, the output is a discrete output with 19 values. That is the 0 for no action, and then 18 possible axes where a unit can move in or shoot onto. So we have 0 to 18 as discrete action space. Okay, next. If we take a look on the general architecture for the training, we used PPO as training algorithm. That's because PPO was successfully used in prior researches, and it has a high forgiveness according to when conducting hyperparameter exploration. And the main focus of our thesis was of exploratory nature. And not optimizing the neural network structure, optimizing the hyperparameters. We used, by default, hyperparameters that was a learning rate of 0.0003 and a clip range of 0.2. Our CNN had 3 filter layers. And originally, the reward or the score given to the players is minus 2 points for each strength point destroyed on the blue side, or +1 for each strength point destroyed on the red side. So we modified that to get an adjusted reward, and the adjusted reward was when the score value in a turn that was achieved is bigger than 0. The reward is the original score value divided by multiplied by the factor, which was the quotient of number of blue units alive divided by total number of blue units. That's the default reward function we used for most of the scenarios. We had one scenario where we used the quotient of the strength point blue still had divided by the strength points blue had at the beginning of the game. Okay, next slide. For the experimentations, we had 8 different scenarios in total with varying complexity. For most scenarios, we trained 5 agents with something between 1 million and 10 million training steps, depending on the scenario complexity. The agents were trained against different AIs that were implemented. So we had one AI, a passive AI that just stayed on its initial position, didn't shoot back. We had a shoot back AI that is an AI that shoots back whenever there is an enemy unit in range. Withdraw AI is an AI that withdraws, so moves to a free hexagon whenever 2 blue units are adjacent to its own position. And when the move AI, that's an AI that with a probability of 40% randomly moves into a free hexagon. For each trained agent, we used 100 evaluation repetitions with most scenarios an increment of 100,000 training steps to collect data. The desired optimal behaviors was determined by manual calculation for the scenarios, and we used the score and the total discounted rewards to assess the performance of the agents. Next.
Okay, now I'll talk about some of the results that we were able to achieve. So we started our research by replicating the 3 boron scenarios that he initially did during his research. So the first of the scenarios that we looked at involved a 2 versus 1 configuration where 2 infantry blue units attack a single infantry red unit that is using the shootback AI as described previously by Stefan. So on the left side, for the first one, they have a fixed configuration where they will remain stationary, or the setup position will remain stationary for the entirety of all of its repetitions. So the simple behavior that they need to show is a massing behavior where the bottom blue unit must wait for the top blue unit, so that way they can mass their forces, or both units can mass their forces simultaneously on the red unit, destroying it while receiving minimal casualties. Let's see. Okay, there we go. So as you can see in the video demonstration, the blue units were able to achieve optimal performance by demonstrating that massing behavior. So next, moving to the middle scenario, we wanted to keep all the formations the same, but now we wanted to move their setup positions across the map for 14 possible setup positions. So during this, they were each, during this evaluation, they were evaluated on the same exact training formations that they were trained on. So during this video demonstration, you could see the setup positions were moved across the map, but they still perform the same exact optimal behavior where they're massing their forces on that red unit. And for the last scenario, we have the 2 versus 1 fixed formations as demonstrated now, but we will introduce a retreating enemy behavior for the red unit. So once 2 blue units are in adjacent hexagons to the red unit, the enemy unit will, or the red unit will start retreating from the blue units, as demonstrated here. So they'll perform the same massing behaviors. Once they mass, the red unit starts retreating. So then the blue units now must learn how to pursue the red unit in order to destroy it before it gets away. Okay. So now the next scenario we looked at was the 2 versus 2, which involves 2 full strength blue units attacking 2 full strength red infantry units. Here they must exhibit the same massing behaviors on the first red unit. Then once that's destroyed, they immediately must head over to the second red unit to mass its units again. So there has to be 2 massing behaviors shown to produce the optimal results. As demonstrated in this video, they start by attacking and massing their forces on the unit on the left, then immediately head over to the unit on the right to destroy it. So to increase the complexity of the scenario, we now had 6 different possible starting positions that each blue unit could start from. So during each training repetition, they will randomly select a starting position that they will begin the scenario with. So now they must perform, they have the increased number of starting positions, but they still must perform the same massing behaviors where they mass their forces on one unit, then immediately shift over to the other ones, as demonstrated in this video. So next, we move on to a 3 versus 2 scenario. So here we're having 3 full strength infantry blue units attacking 2 red units, where one red unit has full strength and the other has a strength of 75%. So here the blue force must start by splitting its forces, where 2 units mass on the full strength red unit while the other blue unit attacks the reduced red strength unit. So now at the end of the scenario, both red units should be destroyed at approximately the same time. So we'll see two blue units go en masse on the left, while the one punches through and attacks the unit on the right, killing both red units at approximately the same time. So now, to increase the complexity of this scenario, 6 different possible starting positions was introduced for each blue unit. So here they must perform the same behaviors with the increased complexity of the startup positions. So the unit starting in the top left and the unit on the bottom, in each repetitions, no matter where they start, are going to attack the unit on the left, while the blue unit that started in the upper right attacked the unit with reduced strength. So after we completed the scenarios, the simple scenarios achieved by Boron, we wanted to introduce an urban terrain hexagon to the scenario to see how we can manipulate behaviors further. So the urban terrain hexagon provides a fixed bonus to whatever force has a unit occupying it. So as long as a force has a unit occupying the urban terrain hexagon, it will continuously receive the fixed bonus. So we wanted to assign 3 different values that the force will receive for occupying the urban terrain hexagon. So on the left, we started with a score of 0. So basically, we're going to create a scenario of where the urban terrain hexagon isn't even there. So as seen previously, the blue units will mask their behaviors on the red unit, destroying it with complete disregard for the urban terrain hexagon. So then next, we provided a medium reward bonus to see what behaviors that the agent will produce. So here they determined that they must destroy the red unit, then immediately occupy the urban terrain hexagon. So you'll see as the blue units start heading down towards the south portion of the map, it will destroy the red unit, then immediately head towards the urban terrain hexagon. Depending on which unit was initially attacked by the red unit, would determine how quickly they can actually reach the urban terrain hexagon. Then lastly, we wanted to see what happens when we provide the largest, a large reward for occupying the urban terrain hexagon. So in this, we're able to have a behavior where it completely ignores the red unit because the reward it receives from the urban terrain hexagon makes the combat not even worth it. So in result, manipulating the value of the urban terrain hexagon, we're able to produce 3 different behaviors that the agents were able to achieve. So then next, we wanted to introduce an urban terrain hexagon that changes its location throughout the map. During training, there were 5 separate maps that will rotate it on a loop, where after each full repetition is completed for each one before moving on to the next map. An additional input layer was provided to the agent, so that way it could recognize, the neural network could recognize the change in the urban terrain hexagon. So for here, only one agent was trained and was able to produce results for 5 different scenarios. So we're going to start from maps 1, which is here. Then we'll move to the right, then move to map 4, then map 5, and the results. So in map 1, they attack the red unit that has the defensive advantage of the urban terrain hexagon. So it's going to take, it took additional time for it to destroy it before entering the hexagon. In map 2, they're going to destroy the red unit, then occupy the hexagon. In map 3, the reward bonus from the urban terrain hexagon makes combat not worth it, and all they will do is occupy the urban terrain hexagon. In map 4, they will destroy the red unit, then continue moving to occupy the urban terrain hexagon. Then in map 5, they will destroy the red unit, then occupy the hexagon. So through moving the terrain, the positioning of the terrain, we're able to produce 5 different behaviors for one single trained agent. So next, so as mentioned before, convolutional neural networks are known for its spatial invariance ability when analyzing images. So we wanted to try and use it to its full potential and achieve a fully spatial spatially invariant agent in one of our scenarios. So we used a 2 versus 1 scenario for this test, and we also added an additional max pool 2D layer after our third convolutional layer. So what a max pool 2D layer does is basically takes the maximum value as it scans over the image for each time it scans. So from here, we used a max pool 2D layer that was 9 by 8 dimensions. So that way it covers the entire activation map that is outputted by our third convolutional layer. And only a single value now is being outputted by the neural network. So we're looking to use this single value of the neural network to be able to produce results where the agent is capable of performing the same optimal behaviors on no matter where it's located on the map, even though it hasn't already been trained there. So in our results, it was able to achieve spatial invariance, but only on the odd numbered set of configurations that was similar to its training. Due to the stretching of the y-axis when using the double coordinate system, when creating the inputs for the neural network, there was a slight difference that was too much for the neural network to be able to determine the difference between the behaviors required. While these issues in this thesis is specific to the training environment that we used, a similar approach can be used in the future to actually train a fully spatial invariant agent, because we did have 6 out of the 14 setup positions produce optimal results, even though it has never seen it before starting the scenario. Then the next scenario we looked at, we wanted to scale up the number of units, the types of units, and the types of terrain far larger than any other scenarios that we tested so far. We basically wanted to see the capability of the neural network and see if this approach could actually be used for larger scale scenarios that have more units and terrain types. So in the scenario, we had 12 blue units attack 6 red units using 6 red units that had to shoot back AI. All the unit types that we have and described previously are used in the scenario. There are 3 types of terrain that are used in the scenario, which is urban, the urban terrain hexagons, the clear terrain, and the rough terrain. As a reminder, the rough terrain and urban terrain provides a defensive advantage to whatever unit is occupying it. The urban terrain hexagon awards a fixed bonus to whatever unit is actually occupying that. Then the clear terrain allows all motorized units to move 2 hexagons on clear terrain in a single turn rather than the one previously seen before. While we cannot determine if the behaviors exhibited in this demonstration are 100% optimal due to its complexity and the amount of moving parts that are actually in the scenarios, we're able to determine that they are actually promising. So as you could see in the video, all 6 units were able to be destroyed by the blue force, and the urban terrain hexagon was occupied, all while receiving only 1 casualty or having only 1 unit destroyed during the scenario. So the blue force starts in the upper right, was able to move quickly, utilizing the clear terrain and destroying the all the units in the red force and occupying the urban terrain hexagon while receiving minimal casualties. So the next, I'll turn it over to Stefan so he could go over our multi-agent training approach that we also used.
According to the multi-agent training at level, the framework doesn't allow competitive training in a way that you train the agents simultaneously. So that is why we did it in steps. In the first step, we trained in a quite simple scenario you see it on the left side, a blue agent, onto a random moving red agent. And what you see is optimal behavior of the blue agent. And the next step, based on that trained blue agent, we trained the red agent. That's what you see in the middle graphic. And what you can observe is that the red unit tends to go onto the rough terrain hexagon. That makes sense because in this terrain, he gets a defender bonus of 0.5, factor 0.5, increasing his chance to defeat the blue player. Based on that, we moved over to a more complex scenario. That's what you see on the right side. We successfully trained a blue agent that in general, moved his 2 units, 1 unit onto the city, the other one into the rough hexagon field on the left side. What you see there is already the final result after training a wet agent based on that trained blue agent. And we didn't manage it to train a proper behavior of the wet agent. So the wet agent only moves south and doesn't behave like we expected him to behave, that he blocks the blue player by positioning his unit on the rough terrain. Okay, next slide. So conclusions and future work. One conclusion is the objectives of the thesis were accomplished, since we achieved in our scenarios optimal, or in the more complex scenarios, near optimal performance of the trained agents. So in general, deep reinforcement learning is a viable tool for develop attacking behaviors and scenarios of increased complexity. However, we realized whenever we increase the variability of the possible setup hexagons, or the variability of the enemy's behavior, that the training steps needed to train agents goes up. That's clear, of course. More complexity means like more training steps. However, for example, for the Alpha Star algorithm that was used for the StarCraft AI, they had the big advantage of having millions of replay data from matches between humans. In military applications, you usually don't have that. So knowing that, for military applications, probably machine learning is a necessary tool if you want to go forward with deep reinforcement learning. And another step for the future, of course, ATLETL is just a framework for educative and scientific purposes. In the future, ways have to be found to implement deep reinforcement learning in already existing military constructive simulations. With that, we are done. Questions?
Okay, great. Thanks a lot, Chris, Stefan. I really appreciate that. We don't have any questions in the chat yet. I was wondering if anybody had any from the presentation. Okay, well, I'm not hearing any. So I'd like to thank both of you for participating. And I think that's great. And I think we can roll right into our next presenter. See, our next presenter is Major Bill Mahan, and he'll be speaking on visual signal training for drivers and their ground guides. So Bill, please take it away.
Okay, good morning, everybody. I am Major Bill Mahan, and the lone Army officer in the senior cohort within the master's degree program. What I will be presenting to you today is my current work on visual signal training for drivers and their ground guides. The purpose of this research is just to analyze the connection between ground guide visual signal training by computer animations in virtual reality and the accuracy of recognition and recall of those visual signals when demonstrated again by a person. My advisors are Dr. Molly McGuire and Professor Perry McDowell. Okay, here's a brief overview of my agenda. As you can see, I'm going to frame the problem, provide my thoughts, and show you where we are currently. I hope you find this presentation both entertaining and informative. Just for reference, my thesis work is 1 quarter younger in development than my peers, so you're going to see a lot more of the sausage making than the actual completed meal. So, currently, we have received internal review board approval for our experiment and are finalizing preparations for our research that we will conduct, and then look to analyze the data over the June-July timeframe, with completion and subsequent publication by the end of September. So here is my context and problem, looking at the on-duty Army vehicle fatalities. Half of the Army military fatalities occurring when on duty during the previous fiscal year have involved an Army vehicle, according to the U.S. Army Combat Readiness Center and the Office of the Director of Army Safety. These on-duty Army vehicle fatalities have steadily increased by 22% over the 3 previous years from FY17 to FY19. Based on my literature review, there was a study. It encompassed over 700 tactical vehicle drivers and the vehicle commanders. Over the course of a year, it reviewed characteristics of training and evaluations of overall effectiveness, and subsequently what they found was bad. You've got these injuries and death and vehicle damage decreasing force readiness. And therefore they decided, they've got to study this and evaluate the driver training and its programs. It was very clear tactical vehicle mishaps were an important cause of injury to service members while deployed and resulted in costly damage to vehicles and equipment. And because of this impact on force readiness, they created a subgroup, the Joint Tactical Vehicle Safety Working Group, and just to kind of study and mitigate these mishaps. And what they identified was the need to better understand and evaluate tactical vehicle driver training, and just as importantly, their vehicle driver training program. So the study went on to say that while the Center for Army Lessons Learned conducted a survey a number of years ago, there was not enough data that was current. But they were able to find all these highlighted components that contribute to military fatalities, including an Army vehicle, whether it was interviews or examinations or the total lack of training. Now, characteristics of the study that shows a majority of drivers are chosen after multiple levels of delegation to mid-grade non-commissioned officers. Once selected, a majority also stated that there were no interviews, medical or psychological examinations either prior to being chosen to become a driver. All are required to occur based on Army regulations. And to compound concerns, some stated that they did not receive training. Now, those that did, whether in a classroom setting, during practical application, or via check ride, did not include ground guiding visual signals training, nor does the training focus on when to utilize ground guides in all suggested and or required situations. So, after reviewing all available Army publications, it's been identified that there is no official ground guiding, no official ground guide training or testing when using visual signals. This is not to be confused with driver's training or driver's testing. The identified Army regulations, Army techniques publications, ATPs, and training circulars, or TCs, they show how ground guiding techniques and procedures are officially interwoven into driving and driver's training, but they, visual signals, are not focused on as a trained, tested, and accredited skill. All right, for drivers, the Army Reg 600-55 Army Driver and Operator Standardization Program is the primary mandate regarding the selection, training, testing, and licensing of personnel that drive Army vehicles and equipment. Potential drivers are required to have an initial interview, physical examination, medical evaluation, and state driver license verification if they're driving off post. And trainers in charge of them are appointed in writing or licensed on the specific vehicle or equipment that the trainee is tested on and has technical knowledge and experience of it. They're also certified by their commanders in writing that they have proper knowledge of said subject material, and usable academic material includes driving ranges, hands-on training, simulations, as well as simulators. And training culminates with a written exam and a driver's performance test. So the road test, as specified in Appendix G, has 3 phases: the PMCS test, the vehicle control test, and the driving test. The vehicle control test also covers numerous familiarizing maneuvers, but nowhere during the road test is ground guiding focused on. AR 385-10, that stipulates commanders will provide training as well as education to prevent motor vehicle accidents. And most importantly, it does state either the senior occupant, who is the senior ranking individual that's present, or the vehicle commander is responsible for the overall safety of the occupants. Now let's move on to the assistant drivers. To enforce safety, the senior occupant ensures the vehicle is operated in a safe manner, assists the driver in identifying unsafe mechanical considerations or conditions, and identifies road or other driving hazards. The motor vehicle operators, they're required to use ground guides according to this regulation, as well as TC 3-21.60, visual signals, TC 21-305-20, manual for the wheeled vehicle operator, and TC 21-306, tracked combat vehicle driver. Assistant drivers are specified to, quote, be familiar with the vehicle operations and trained for ground guide duties, end quote. It also specifies ground guides are required when backing up or when moving within a motor pool or an assembly area. While there's no identified training for this in a more detailed subsection, standard areas are at least identified for using ground guides during rail vehicle transportation, at construction sites, when backing, or when needed to view the area for possible hazards. And then, of course, the Army Traffic Safety Program, that is AR 385-10, it's mentioned as being a requirement for all soldiers, not just drivers and assistant drivers. In Appendix E, it shows an example examination of 22 questions. Unfortunately, nowhere in this entire process to include the questions incorporate the subject of ground guides or proper hand and arm signals. And as for the ground guides, upon examination of TC 21-306, ground guide procedures listed specify they're to be used when there is doubt about proper clearance in cantonments, parking areas, bivouac sites, when they're moving in reverse, as well as during limited visibility. And TC 21-305-20 identifies similar detailed procedures. While not specifically identified by the Army Safety Program, ATP 411, I believe, is the only publication found that even specifies the assistant driver to assist as the ground guide. And this can conflict, as the assistant driver may also be the ground guide when necessary. These publications also referenced annual mandatory training of the online Army accident avoidance course, but this too did not cover ground guides. And as a side note, as of April 18th, 2018, the Secretary of the Army published a memo prioritizing efforts. It is Readiness and Lethality Update 2 that stated this isn't even a requirement anymore. But ultimately, the most overlooked component of driver training is the use of ground guiding with visual signals. In many instances, drivers' failure to use a ground guide caused the accident. Standardized common knowledge of ground guiding procedures must be included in unit training and used to a greater extent to assist equipment operators in identifying potential hazards, obstacles, and personnel they might not otherwise see. And addressing this problem will give the Army a greater capability to adjust their input and training strategies, improving standardized common knowledge of ground guiding procedures for the selected drivers, as well as contributing to a more nuanced sustainment training technique to combat current trends in military fatalities. So Patel and McDormand, they investigated persuasion effects by computer animation in comparison to the pre-recorded live action counterpart and found that the animations can be persuasive even when not human-like in appearance, as long as the animation is portrayed as having authority. In their study, the human in the pre-recorded live action video and the animation both maintained matching appearance, eye contact, and standard clothing, as well as audio tracks. This influenced their levels of credibility with the viewer. And the pre-recorded live action video and the computer animation gave all combinations of responses. They had identical as well as contradictory in 4 separate videos. The participants then assessed ratings for appearance and credibility with subcategories of appearance by way of attractiveness, eeriness, and humanness. That kind of leads off into the uncanny valley. For credibility subcategories, they encompass trustworthiness, competence, and goodwill. And ultimately, it all boiled down to the fact that basic understanding is rooted in just how much the avatar can influence people, with the highest quality representation being the most persuasive. And the paper states computer characters can be more persuasive than a real person while being perceived as less credible. So fundamentally, if we can ensure credibility by utilizing proper appearance, eye contact, and audio, we can use computer animation to appropriately persuade and train. In addition, VR training can be equal to or better than equivalent real-world training. An example of this is in other settings, such as teaching children safe road crossing skills. They've shown slightly better scores than professional human instruction. As an offshoot of this, the Air Force Air Education and Training Command started what's known as the Pilot Testing Next program in April 2018. Their initial attempts to decrease pilot training time on various platforms, such as the Hornet, H-60 helicopter, F-35, C-130, and other headsets, saw pilot training and certification / graduation decrease from a window of 1 year to 4 months. Now, that's a picture of them on the slide right there. Consequently, they also found themselves less inclined to spend money on legacy simulators that cost more than 10 times the amount. $4.5 million in comparison to a VR simulator bay setup, which would be $300,000. Arguably, this ultimately increased efficiency of training, time, instructor personnel, and their overall budget. Likewise, the Air Force Academy cadets, they also cumulatively showed improvement in aviation training. Cadets without any aviation training claimed to have increased muscle memory and better self-confidence. This additional capability provided not only repetition, but showed positive correlation between early participants in their VR training and live flight performance in powered flight. So how can we take all of that information, knowledge about training gaps and the validity of VR training, and test it with a basis in our focus? So this is what I came up with. These are the 4 approved research hypotheses, and I'm very excited to find out what the research shows. The first one, visual signal training using these animations in virtual reality are going to be easier to learn than visual signal training just using a pre-recorded live action in the same virtual reality environment. Secondly, when given a choice between the two, people are going to prefer the animations. Third, when attempting to recall those visual signal movements as well as everything else, the recall is going to be better for those computer animations in virtual reality than the pre-recorded live action. And finally, people will identify real-world training movements faster, and when having been trained using computer animations in virtual reality compared to pre-recorded live action in virtual reality. And I'll show you a couple of videos here shortly so you'll really be able to see what I'm referring to. We're going to use the following 11 hand and arm signals that control the vehicle driver. And this could ultimately benefit the military by not only the training techniques, but also doctrinal adjustments found in the Army regulations. Now, we're not trying to capture all of the potential visual signal and hand arm signals for ground vehicles that could be used for mechanized movement techniques or traffic control or convoy control or things like that. There's a lot more if we were to go in that direction. But what we do want to do is be able to synthesize this data and knowledge into a white paper and article for Army consumption within the Army Combat Readiness Center, as well as the Center for Army Lessons Learned. So here is the design methodology. Participants will be exposed to both training stimuli and then optimally tested at 2 times, once after the training and then another time in follow-up testing. Speed and accuracy will be the dependent variables used to measure the differences between the conditions. The virtual environment was constructed to mimic the context of the videos that I should say came directly from the U.S. Army Combat Readiness Safety Center. And this training is built to mimic how the real interface would be encountered and learned from. The types of data we're interested in for the study is the time to complete the task, the success rate, recall and recognition accuracy, and user satisfaction as to how much they like or dislike the live action versus animated simulations. On the next few slides, I'll show you a quick preview of the software animations that we created. These are the same actions and titles as the live action videos. Okay, so I'm going to play 2 videos for you. This is essentially what the participant sees when they put the VR goggles on. You might notice the video is not static. So how we're going to work this is the experiment will occur, like I said, in 2 parts. The first visit, you do the standard paperwork. Once that's complete, participants will put these VR goggles on and begin the learning segment that you're seeing right now with a combination of both avatar and live action demos. Now, prior to the start of the videos, the participants are going to be allowed to familiarize themselves in the mixed reality environment. They'll be able to look around, although that's not necessary. There won't be any inclement weather or extraneous sounds. I'll essentially instruct them to look forward and pay attention. Each selected video movement will be played for 1 iteration at full speed and then at half speed before transitioning to the next video. And it's only during the learning or the training phase will the videos be played at the 2 separate or different speeds. And this is just the general montage that you're currently seeing. I'll let it play just a little bit longer, just so you can kind of take it all in. And we're going to go ahead and move to the next video now, just to help keep us on track for time. So when they're done with training, there'll be a break for the simulator sickness and system usability forums. But this serves another purpose. The break will ensure testing is an effect of memory and not mental rehearsal. Once that's complete, testing in VR with a random combination of live action and animated video signals will happen. And that's what you're seeing right now. You notice there's no title there on any of them. And additionally, all of these data points are going to be recorded in an Excel .csv file. After this testing visit, there will be a secondary visit that will consist of just a testing segment involving an in-person delivery of the hand and arm signals. And that's where we'll collect additional data on their intermediate knowledge retention and recollection speed. We realize it's not feasible to have everybody test 2 separate times, and they're not required to, but we don't want to limit our testing if we can extrapolate really advantageous information of the VR training into real-world capabilities, provided the hypotheses hold true. And really, what we're trying to get to is the fulfilled capabilities to provide the military with evidence of alternative training that's going to increase the overall safety of people, by using the virtual environment. Additionally, this will provide information on the impact of recognition and recall between visual signals, and it will help guide future training as well as, I'm sorry, I lost my train of thought there, as well as policy drivers for future employment and development. We need to utilize all of the current technological capabilities. VR, I do believe, is a viable yet underutilized resource in the Army that shows us that it can speed up initial learning, periodic refresher training, and also ensure proficiency is maintained for hopefully longer periods of time. Currently, I don't have any results as we're still working on one minor facet of the simulation, but I'm very excited about the possibilities that this research will uncover. I believe there's a real chance to expand on the training element, but a lot of my recommendations will hinge on analysis of the data. So, and with that, I want to thank everybody. If you have any questions, feel free to ask, or you can also email me. I'll put my email in the chat for easier reference. And if I don't have any specific questions, I can kind of tell you the reasoning behind why I even wanted to do this study, if anybody's interested.
Yeah, Bill, I think that'd be great. Why don't you go into that a bit?
Okay. So a long time ago, way back in the day when I was an enlisted soldier, this had to have been somewhere around, I'm going to date myself, 2008, roughly. I was at Fort Riley. It was the winter time, and our first sergeant had us in a big company formation and told us what had happened. There was a very large accident, and this was actually the first accident I had ever been a part, well, not directly, but indirectly a part of during my military career, and hopefully my last. But what happened was the first sergeant told us specifically, hey, we had a fatality in the motor pool, and I just think, how can that even happen? What are you talking about? And it was wintertime. There was ice in the motor pool, and somebody was ground guiding incorrectly. They were walking backwards. There was only one ground guide guiding a vehicle. The vehicle was also moving in reverse, and they ended up slipping on the ice, falling, and they got ran over, unfortunately. And that has stuck with me for so long. I just could not believe that such a simple fix couldn't be found for this issue. And it all goes back to safety and training, and I can't change the weather conditions, but I can definitely train the hell out of you. I'm sorry, pardon my French, but yeah, I can definitely train you to do the right things at all times. And that's not just the person that's doing the ground guiding, but that's also the driver. It takes two to tango. You need to be able to see the ground guide, know exactly what they're telling you, and that ground guide also has the requirement to be able to do the right thing at all times to be able to effectively communicate with that driver. So that's really what kind of helped fuel this. And I want to give a special thanks to both of my advisors on this, because they've been able to indulge me in my quest to kind of help the Army. I was really surprised by just exactly how many fatalities for such simple things there are. So, and that's it. That's all the story time.
Okay, sounds good. Now, it's great when we get students who come in with a strong passion for what they want to work on their thesis. I think that's really awesome. I think we've got some of our best theses out of it that way. So thanks a lot, Bill, for a great one. Does anybody have any questions? Okay, well, if not, we'll start our next break a little bit early. Be back at 11:30 Pacific, please, and we'll start have our last two student presentations then. And great, thanks a lot, Bill.
Yes, sir. I appreciate it. Thank you.
Good morning or afternoon to those on the East Coast. I'm Captain Chris Garibay. I'll be going over my thesis. The title of my thesis is Applying Federate Simulations in Distributed Operational Environment to Conduct Dynamic Logistics Staff Training. All right, so for the agenda, a little unconventional, but fitting as it mirrors the same step process in distributed simulation engineering and execution process within my thesis. My thesis advisor, Dr. Kurt Blaze, co-advisor, Christian Fitzpatrick, and the second reader, Dr. Quinn Kennedy. All right, so going into, so within my research design, I focused on was the federation that would increase the cognitive load on logistics staff to ensure their future readiness to manage time, space, resource availability, and consumption rates, and potential engagements with peer adversaries in maritime and littoral environments. As you can see, stated by the comment on the Marine Corps Planning Guidance under the EABO subsection, to date, our wargaming has focused on limited set of scenarios. Thus, we'll need to expand our analysis across more scenarios to better inform our force design efforts. So basically, starting with the new innovations that are developed into concepts and concepts that are tested and redefined as wargaming experimentations and modeling and simulation. Again, so what's the point of this? It lines up with 2019 comment on the Marine Corps Planning Guidance as he dives into two things, one being distributed operations, and two, not necessarily word for word, but constructive simulations as it ties into the LVC community. All right, so a little quick background that drove the framework of my design objectives for this research is derived from two prior studies done at MOVES, starting off with Captain Emily Kennard in 2018. Biggest takeaway here was that towards my study was that she looked at JDLM and how it met the needs of logistics support through constructive simulation. Her recommendations was to increase the complexity of the scenario and federates. She also recommended a deeper dive into the constructive simulation. So she looked more of an analytic part of it and MTWAS and JDLM and found that that was able to fit the needs in some shape or form and logistics staff process. Again, limited scope within the 6 functions of logistics that the Marine Corps looks at. Next one was done in 2019 by Captain Courtney Thomerson. Conducted a study that with a deeper dive into 3 main constructive simulators. That was JDLM, MTWAS, and JCATS. She looked at the federation between them and which one would provide a larger scope in the logistics community when it came to training. Biggest takeaway here is that JDLM was the prime source for logistics staff and best fit for the federation. She found that JDLM and JCATS were the best fit. However, more practical federation, given the constraints or the restrictions of the DoD or the Marine Corps funding, was that JDLM and MTWAS was ideal federation fit for the Marine Corps. Again, her recommendations was to try to exploit other simulations that could be federated within JDLM and provide a larger aperture towards the logistics community in order to improve the logistics training. All right, so a little background going into this. Quick snapshot of 3 simulations that was captured within the last 2 studies by Thomerson and Kennard. Overall, each one provided its own capabilities, but no single or combination of the federation provided all logistics functions in one package. This is important information as as I use this to compare against a new constructive simulator that in order to federate, and it basically drove the background my questions, which is one, basically trying to federate simulations, creating a distributed operational environment to support logistics command or combat element staff training. And two, using JDLM and VR forces as a combat simulation, be federated to create a rapid decision-making model, enabling logistics staff to execute logistic operations through management of time, space, resources, and consumption rates. All right, so perform conceptual analysis. So next step is was taking VR forces, which is the one that I looked into with federating with JDLM, and looking to see the feasibility of federating and the larger capability of logistics functions it can provide. Starting off with funding from ONR, I worked with Mock Technologies to create a larger distributed maritime scenario. I basically replicated a tsunami in the heart of Sulu Sea near the Philippines. It's a large multi-day aggregate level scenario simulating a MAGTAF response. The overall objective of the MAGTAF was to respond by providing humanitarian aid. Biggest takeaway from this slide is from the scenario, it spanned off from 4 different countries near the South China Sea. It tested all the different functions that when it came to Marine Corps logistical actions and the 10 classes of supplies. Overall, it was able to simulate all 6 functions of logistics to include the 10 classes of supplies with additional extensions in the scenario. With that being said, it was provided that VR Forces has the necessary capabilities to implement the necessary logistic functions outlined in the Marine Corps. However, it did lack finite details such as NSNs or DOTICs that you normally would find in these simulators, constructed simulators. So this right here is just a quick snapshot of what the scenario looked like in one of the areas. As you can see in the top of the screen, the bullseye, those were the heart of the earthquake, or the earthquake and epicenter of the earthquake and the tsunami, and hitting different points within the Philippines, Malaysia. All right, so prior to beginning the experiment, the JDM Federate required an OBS file, which created an joint training data system, JTADS. As you can see, the images from the web-based services service that supports and generates order of battles, terrain, weather, basically supporting the M&S community in creating these scenarios. The file was a direct object-to-object mapping of the aggregate level entities containing in the EABO scenario developed in VR Forces. The OBS file created a map directly to the OOB file used in VR Forces. All right, so this is the hardware configuration that myself and Chris Fitzpatrick created in the MOOS laboratory. Realized that creating the federation wasn't going to be a simple connection, but taking many considerations that we had to account for and executing the experiment provided a little clarity on the issues that needed to be addressed prior to creating the federation and applying it to the logistics staff training. So to design the experiment, looked at the software and the data files. For example, the .rdr file, the .mtl file, options available to create the federation, specifically looking and focusing on the RTI and the FOM files. So as you can see, the first table, see the file types and the software that I used in the experiment. For the first experiment, I used the mock RTI with the Reaper FOM to create the initial federation. The goal of the experiment was to ensure we were aligned with the federation and federate rules, as you can see the table below 1 through 10. So prior to the experiment, the intuition was that these rules were too general, but had to be confirmed through the experimentation. In addition to the HLA rules, we also needed to account for the services provided by the RTI. And those services are divided into 7 basic groups, which is the federation, declaration, object ownership, time, data, distribution management, and support services. So when we deployed the federation, along with Wireshark and Disk Spyware, which are proprietary packet inspection tool. This spyware is used specifically for mock technologies. Once the scenario was deployed, the data was being transferred, as we saw from the RTI forwarder and mock technologies RTI. During the execution, the HLA listener did not receive any of the data or interactions within the Federation, which highlighted rule number 4. So there needed to be some modifications to the FOM that included the interaction known to JDLM. Upon investigation of the XML file, the extensions required for the FOM were added and could potentially be recognized via interaction between JDLM and VR forces. So talking with the engineers at Joint Staff J7, we basically received the recommendation to utilize the RTIS D36D with the JLVC FOM to test the feasibility of creating the Federation using tools not within the mock suite or systems, which we use for experiment 2, as you can see at the top of the table. Experiment 2 deployed both the RTIS and the D36 and the HLA listener, and again using the Wireshark and disk spyware to observe the data transfer. Viewer forces did not start as there was a runtime, a RID runtime initiation data file error. Through the investigation, basically learned that the .ntl file used was a proprietary format used by Mock to create the Federation. So in all cases, this file format would be unusable in creating the Federation, and deemed that the gateway may be required to facilitate the transfer of data based on the incompatibility of the file formats. In the last experiment, we try to federate VR forces to VR forces using the RTIS with the JLVC FOM. Given the errors, came to the conclusion that the gateway specific to VR forces and JDM Federation must be developed. Basically, a gateway is a translator that links together simulations that use dissimilarity underlying simulation architectures or data file formats. In our case, this would be the RTI.RID file, compatibility with the RID.ntl file. So in order for these two models, the JDLM and VR forces to communicate with each other, need further development will have to be conducted on either behalf. The HLA Federation must meet three criteria, one being the FOM, RTI, and the model behavior. So by implementing the new RTIS, it was also recommended that the RTI gateway be used as a workaround in the interoperability barrier. The workaround between the two RTIs allows the federates to connect and communicate via the RTIs. This would provide the necessary means to interact between the RTIS and the mock technologies RTI. Also, the JLVC FOM that was derived from the rear FOM had some differences. The JDLM used different objects, interactions to collect the logistic data and perform routine logistical functions. Moving on. So wrap up and future work. Basically in conclusion, to meet the defined simulation environment objectives using the scenario developed in VR forces, a gateway has to be established between mock technologies, RTI, and the HLA listener. Additionally, the JDLM provides a unique logistics model in which it parses the FOM instead of the programming to an exact version. After the JLVC parses the FOM, the model searches for the required information and only reports an error if the behavior or the data of the entities are not located. So basically, if the entity behavior is not located, then the execution will neither be stopped nor the request rejected to join the Federation. So in order for the VR force to federate to JDLM, it will have to adjust the JLVC FOM required a translator between the simulation and ensure all behaviors basically align when objects interactions are updated. Also, this was proof of concept stressing VR Force's capability, showcasing that it was able to meet the 6 functions of logistics and the 10 classes of supplies. Yeah. All right. That was pretty quick, but in comments, do like to say thanks to Mock Technologies, Tapestry Solutions, and J7, as they provided a lot of helping hand into this.
Okay, great. Chris, thank you very much. I appreciate that. That's some interesting work. So one thing, let's see, are there any questions out there for Chris before we move on?
Hey, Chris, this is Matt Morse. Got some questions for you. Could you go into a little bit what the split is on representation of logistics functions between VR Forces and JDLM? Because when you look at let's say MTWAS and JDLM coupled together, you can still use MTWAS for all the fuel consumption, the incursion of damage, and the chow and the water consumption by all the entities or the aggregate units inside of MTWAS. And you're tacking JDLM on there to support all of the maintenance and the medical functions that MTWAS doesn't support. So can you identify what it was that you were looking to use VR Forces for as far as logistics functions, and what you were looking to use JDLM for? So how you'd be passing entities back and forth between them to affect those different logistics functions?
Yes, thanks. So looking at prior research from Emily Kennard and Thomerson, I mean, it was outlined that there was probably the biggest gaping hole out of everything was the supply capabilities that each one of them provide. And I know you're probably very familiar with JDLM and MTWAS, as MTWAS is more of a combat simulator, and JDLM really isn't necessarily a combat simulator, but in some shape or form, it provides that lack of logistics that that MTWAS and JCATS doesn't provide, that it doesn't have. So with VR Forces, within additional simulation object extensions or plugins, we're basically able to create and refine the maintenance capabilities, the health services capabilities, the services capabilities, those postal services that you normally only see in JDLM that you don't see in MTWAS and JCATS. And then like I'm trying to think of MTWAS, the supply capabilities. I know supply capabilities captured in MTWAS are only 1, 3, 5, and 7. JDLM captures the rest of those, but having a simulator or simulation that can capture all 10 and all 6 functions of logistics just provides a little bit more fidelity. In addition, that VR Forces is also an out-of-the-box simulation. The ability for me to work with VR Forces on my personal laptop narrows down the hardware that is needed for these constructed simulators. Does that make sense?
Yeah, I mean, the fact that you got a lot more logistics functions able to be represented in VR Forces, I wasn't aware of all of that. But the real question is, what are you getting out of VR Forces and what are you getting out of GDLM? How are you splitting logistics functions execution between the two? Because you have to decide that to determine, let's just say maintenance. JDLM has a lot of maintenance simulation capabilities. So for VR Forces, are you breaking something and then passing that entity over to JDLM, having to go through all of the maintenance functions, processes, have the repair parts tracked within JDLM, fixing it, and then passing it back over to the owning unit within VR forces? Is that how you were addressing that?
No, it's actually the opposite way around. As of right now, it's going to JDLM. Just due to the fact that VR Forces is so new and it doesn't have, as we found, a lot of the, it would need JDLM as of now to execute those functions. But trying to scratch more of the surface off that VR Forces has those capabilities and may not need JDLM to provide different functions or different different functions.
Yeah, that's interesting. I definitely want to talk to you more about how those functions relate between the two. Just one other follow-up question for you. You mentioned that VR Forces doesn't support the NSNs. So did you have to figure out some way of mapping between VR Forces method of representation of supply item types to the NSNs that are tracked within JDLM? And did you just use the OBS XML to be that kind of Rosetta Stone between the two of them?
Using the OBS file, basically being the Rosetta Stone between the two of them, using JTAD's to create that OBS file within JDLM for JDLM.
Okay, gotcha. Thanks. Yeah, definitely want to follow up and talk more about this whenever you get a moment. Thanks.
Great, thanks a lot, Matt. Hey, John Richardson in the chat has come up with a question about what about perishable supply chain logistics for JDLM, such as blood and items like that.
Sorry about that. So for JDLM, classes of supplies that it's able to support is 1, 2, 3, 4, 5, 6, 7, and 8. And blood being split between Alpha and Bravo, being 1 not being blood and 2 being blood supplies. VR Forces was able to split that and show representation between actual blood supplies and non-blood supplies. Did I answer your question? Was it Richardson?
Sort of. It was more of a question of since this is logistics in a distributed simulation, if you have logistics simulators that actually are interested in supply chain optimization or supply chain logistics related to items that have critical time. In other words, some of the characteristics in your talk were who maintains the object, what type of maintenance is involved. But it seemed like if you do anything with medical, it does require a time, an expiration date, sort of. And that's what I was just interested in.
Are you interested in the VR Forces aspect of it? Is that what you're asking, sir?
Well, if you, in other words, if you have time and expiration dates and for certain logistics items and or even non-perishable items, how does that affect anything related to distributed simulation? For instance, how do you have to modify the FOM to say, oh well, at simulation time T1, you have to have other supplies delivered at simulation time T2, or else there's issues and stuff like that.
And so one of the things that you'll find is JDLM updates every 3 seconds at a heartbeat. So the key was also trying to, in VR Forces, provide that same heartbeat of updating blood, specifically blood, time for maintenance services, capabilities, a lot of stuff in the health services, and providing that 3-second update within VR Forces as well. So that was something that that would have to be adjusted within VR Forces, which it can be done. Unfortunately, time was on my side and wasn't able to do that portion of it.
Hey, John, Matt Morris here. I have never seen any sort of perishability of supplies in JDLM. The closest thing to it that simulation supports is you can have casualties expire if you don't get them to the next level of care within a specific amount of time. I don't know if anybody uses that because that's pretty difficult doing that as well. But part of the problem with the supplies piece is you'd have to have an initiation point for when you're saying blood was drawn, and I believe you can do some sort of walking blood bank function, but I don't think there's any perishability representation in JDLM, and I would really doubt that there would be anything in VR Forces either for that.
That's fine. Thank you very much.
Excellent. We've got some time for one or two others, if anybody's got one. Okay, I just want to point out, one of the interesting things about this is that, there's a lot of things that you can go out there and you can look at, wow, it really should work. Should I be able to connect this with, this RTI? Should I be able to, set this stuff up? And a lot of times until you actually try to build it, you can't find out that things won't work like that. And I think this as well as, Alex White's with the issues that they ran into with trying to run the simulations over the VPN, those things may not be intuitively obvious when you're just thinking about it. That's a great thing of actually going out and trying to do these things, because the devil is always in the details, and there's always things that are going to come up and cause issues. Okay. Well, now let's move to our final presenter of the day. We've got Captain Max Schlessel. He'll be presenting on his thesis work. And go ahead and take it away, Max.
All right, Perry, are you able to see the slides there?
Yes, I can.
Okay, awesome. Good afternoon, ladies and gentlemen. My name is Captain Max Schlessel, like Perry said, and he also mentioned a little bit earlier that I'll be graduating in September. So thankfully, I've collected most of the data for my thesis, and I'll be presenting that here. But like he also mentioned, my thesis won't be available on the next drop on on the Dudley Knox Library page. I'll be finishing up in September and graduating then. So a lot more work to do, but definitely have made some headway and really excited about it. So framing it here, in Force Design 2030, the Commandant of the Marine Corps in general asks for a more capable and mature infantry. And at the end of the day, the average infantryman, maybe in the long run is going to get older. And we're going to get some more leadership changes in there with our squad leaders moving over to staff sergeants instead of sergeants. But at the end, but we still have Marines coming in who will be part of the infantry, and they're not going to be magically more mature. So how are we going to accomplish this? We don't have more training days in the schedule. We still have 365 days in a year. And, we don't have all this money to send these guys to these great SOCOM schools or anything else. So how are we going to get this more capable and mature infantry? Well, other than making, staff sergeants the standard squad leader, I think we're going to do this through a lot of different simulations. And we do have some great infantry simulations right now. But looking over the past few years, we had this tactical decision kit that came out in 2017. That's been divested, but it includes some great MSI hardware, a lot of software to include VBS3. It included this ITDG program that was developed by ONR in 2016 and 2017 for tactical planning purposes. It included HoloLens, which integrated really nicely with that ITDG software. And it also included some Microsoft tablets and a few other things. Unfortunately, those are getting divested. So it was a great program. It went out to all the infantry battalions, and I think it was definitely in the sphere of making a more capable and mature infantry. But unfortunately, for a lot of battalions, they collected dust, and that's why they got divested just a few years after their implementation. There's a lot of interest in man-on-man teaming, and of course, use of UAS and things like that. They came out a few years ago with the Quads for Squads program, getting an Instant Eye or some other quadcopter type of UAS into every squad in the Marine Corps, and that's great. And so we're going to continue to work on that. But at the end of the day, Marine Corps simulations that we have now are a lot of times bulky, and they're kind of low fidelity is the perception. So here's me. I've been working on this. As soon as I got to 2nd Battalion, 6th Marines, they were hooking heart rate monitors up to me, and we were studying cognitive workload. ONR was down, every month looking at developing this tactical decision kit, and we did a lot of good work then. But I think there's definitely some ways to go. So I looked at the question of, training squad leaders with VBS3. Right now, VBS3 has a lot of different uses. We can use it to rehearse. We can use it for force on force. You can put a team or a squad or a platoon against another unit, and we can see how they do. But I really want to look at how do we make squad leaders better and more mature and more capable, because a lot of times that's what's filtering down and influencing the rest of the squad, obviously, is how great that leader is and how well they're able to manage the assets they have, whether that's unmanned systems or technologies, their radios, their equipment, but also lead their individual Marines. So looking at how well we can use this simulation to specifically train squad leaders is what I wanted to do. They have a greatly increasing workload as new technologies emerge. So as we include this quads for squads kind of concept, now they've got multiple UAS in some cases within their squads. They've got new assistants within the squad, such as the squad systems operator concept, who's going to be managing that technology. And it's not just UAS, but it could be robotics and so forth. They've got newer, more capable radio assets. So 117 Golfs with ANW2 networks. They've got the MAG tabs, or the Marine Combat Handheld Tablet systems. And then, of course, as always, they're communicating with higher and to those other assets in the squad, like JFOs. They're communicating to fire direction centers or their platoons, their higher headquarters. So they've got more going on than ever before. And I don't think that's an understatement by any means. And we need to figure out how we can better train and make them more mature. And so I kind of did that through the lens of looking at it with VBS3. So looking at how, the main question here is how can we use an interactive synthetic environment, in this case VBS3, to generate feedback concerning task saturation management of small unit leaders, such as squad leaders, better than is currently done. And then how can we increase interoperability as well? But at the end of the day, looking at how we can really train, evaluate, and look at workload management with squad leaders. So again, I really took a lot of interest in this topic because I think it's a segment that we're missing. A lot of attention is getting paid to staff planning, and all these great simulations that we have for that. We're building the Wargaming Center in Quantico, which I'm really excited to get a look into, and especially as I transition to CDNI under the Marine Corps Combat Development Command in Quantico. I'd love to work on that thing, but at the end of the day, that's a staff planning tool, and most of our Marines, fall into just a few ranks of E3 to E6, and that's 64% of the Marine Corps, 118,000 people. And so how are our simulations and how can VBS3 and these interactive synthetic environments affect those guys? Of course, they're not all infantry Marines, but it still shows that by and large, 64% of our rank falls between E3 and E6. Unlike the other services, unlike the Air Force, the Army, and the Navy, we are not a top-heavy organization. Only 10% of our force is officer corps. So, as much as we need simulations to help our officer corps out, again, to get back to what the Commandant is looking for in Force Design 2030, what the Marine Corps needs, a more mature and capable infantry is not going to come from, training the top 10% of the Marine Corps. It's going to come from making sure that the ranks that matter, that E3 to E6 sweet spot, are trained and have the tools and assets they need to be more mature, more capable. It's not going to happen overnight. These guys aren't going to get older. There's not going to be more training days or more ammo necessarily allocated in the calendar. It's going to be through how we are able to conduct ourselves through simulations. So in the experiment design that I came up with, thankfully I had a 2nd LAR as a sponsor. Lieutenant Colonel Scott Cuomo with 2nd LAR is a tremendous Marine, and he came up with some of these concepts, such as the squad systems operator concept. And he was really interested in a lot of this stuff. So for the experiment design, we had pretty much 2 groups. The first was given introductory controls training for VBS3, and then they were given some advanced call for fire, CASVAC, and UAS control training. So what that looked like was, for instance, for the introductory controls training, Group B and A were just able to see, okay, this is what your squad systems operator sees. This is how you can, control some of the very basic functions of the UAS within the simulation, and this is how you kind of navigate some of the user interface. But what Group A was given was they were given some rehearsals. So they were told, okay, here's your UAS over this target right now, and this is how you can see it. Now we want you to tell your squad systems operator to move it over your current position, which was about 2 kilometers to the southwest. So we actually had them do that. We had them say, all right, my Bravo over the radio, hey, 1 Bravo, this is 1 Alpha. Can you move the UAS overhead my position? And so we actually had another Marine that was playing the part of the squad systems operator, and they would move the UAS over, and they could then see what the operational picture looks like. They could see their own position on the ground. They could see their own avatar, and I think that was quite effective. So that rehearsal again was the difference between Group A and Group B. Again, trying to see how we could improve that cognitive workload performance by giving them those extra sets and reps within the simulation, and seeing how much better they're able to utilize that squad systems operator given that training. So some of the metrics we used was task completion. So we looked at their a lot of different reporting procedures. So their salute reports, which is gives enemy disposition, composition, and strengths, as well as orientation. We looked at their call for fire reporting. We looked at their pause rep reporting. We looked at to include how they control UAS, because that's not a standardized report. And we also did CASVAC reporting. So looking at how well they could complete those tasks. We used heart rate monitors, the Empatica E4s. Those measured body temperature, heart rate, galvanic skin response as measures of stress. We used pupillometry tracking, which measured the pupil dilation and constriction as indicators of stress, and then also where they were looking at in terms of areas of interest on the screen. So we counted the times that they were able to look at the menu and go back to the menu and see how often they wanted to kind of use that UAS and how often they were thinking about it. The pupillometry tracking software with GazePoint, it also tracked their cursor clicks and then where their cursor was on the screen as well. So again, we were able to define multiple areas of interest on the screen, see what they were looking at and how often they went back to those areas of interest. And then at the end, we gave a standard cognitive workload questionnaire using the TLX method to see kind of what they thought of this and where they thought their own cognitive performance was. So again, in experiment design, they were given a GRG or map of an actual mount town in Camp Lejeune, which we recreated with pretty high fidelity within the simulation. So the exact grids that are used in real life, such as this Google Earth imagery, were the exact grids that were able to be pulled in the simulation. So they could reference both this map, just like they would have in real life, with what they were seeing and getting as far as position data within the simulation. They were also told, for instance, that all of the building numbers on this GRG, this map, was also the same building numbers that their COC and their squad systems operator had. So again, they went into it. They were given the role of the squad leader in the situation. They were told that LAVs had dismounted on the east side of the city, that they were holding security. They could not push into the city as it was unsuitable for LAV traffic. And then their task again was to recon mobile mount, or this facility here, this town, in order to allow for follow-on clearing operations. So they were given a reconnaissance task, and we kind of evaluated at how many of them, knowing it was a reconnaissance task, leveraged their UAS immediately, and how they leveraged their squad systems operator. How many of them wanted to see the actual picture versus how many of them just said, hey, to their squad systems operator, how many just communicated, what do you see on the ground? What are you able to see in the picture, while they were kind of controlling other things and looking out over the city. Again, they start the scenario with the UAS overhead. They're told that, hey, the squad systems operator has the Raven overhead. Again, trying to figure out how they're going to manage that and leverage that. And then also for communication, we used, everybody had a headset and microphone, and they used the CNR Sim, that's Combat Net Radio Simulator by Calatrix. You can see on the bottom right here is the kind of the integration and interoperability of that network right there. And, up here it says VBS2. Out of all of the different DIS voice entities that we tried out for the simulation, there's even, VBS pitch to talk, and there's VBS radio within the simulation. But a lot of times with the firewall setup, which can't be changed on the DVTE computers, among other things, it didn't really work so well. But this CNR Sim works phenomenally. Honestly, it says VBS2 AAR integration because this version of CNR Sim that is on the current DVTE laptops is a 2009 version. But it worked really, really, really well. And the Marines had a really positive response to that. And it was also interesting to see how they use it instead of just, of course, turning to, the people at the table here. So you have the participant for the experiment. You had their squad systems operator. They were, for call sign purposes, the participant was 1 Alpha as the squad leader. Squad systems operator was 1 Bravo. They had a fire direction center that they could call up for call for fire. And then they also had a company operations center for that they could route CASEVAC requests through, as well as salute reports, sit reps, things like that. Here's some of the screenshots that they saw. So they were able to get this vantage point over the city. And again, it was a recon task. So it was interesting to see, when this first comes up, how many of them kind of default to the squad systems operator, default to the UAS picture, but also how many of them just wanted to kind of innately push into the city. And we got a lot of really good responses. One of the first guys that went through as an LAV crewman said, if I'm engaging with my LAV, it's a bad day. They're supposed to be, a little bit more covert in this reconnaissance type of mindset. And he said, at first I really wanted to push into the city, but I realized that I had that squad systems operator to leverage off of. So in some of the outcomes here, so right now, kind of in the data pre-processing kind of realm and looking through all of the data that we collected hundreds of gigabytes of video data, of the screen replays, of pupillometry data, and as well as the biometric data. So up here we have one of the biometric graphs, and I was really pleased, as I'm going through the pre-processing and looking at seeing this. So up here we have EDA, which is the electrodermal activity sensor, showing that galvanic skin response, and that's measured in microsiemens. And as we see the training scenarios go on, so you have the introductory training, the more advanced training, and then they go through the same baseline scenario. And we pretty much got exactly what we want to see throughout the entire thing. We have this increased electrodermal response, that increased quite significantly over the course of the experiment. So we do see that their cognitive workload and stress indicators definitely increased. And then you have the kind of the macro level of that as well as the micro level. Down here we have BVP, which is blood volume pulse, measured by the photo plumograph within the heart rate monitor, and that really corresponded nicely as well with a lot of the individual tasks that we were asking. So as we go through and we see, okay, this was a UAS control task, this was a call for fire task, this was a CASEVAC task, and we do see that we have some positive response. I don't think this is anything new though. I think back in 2017 when they had the picture of me with the heart rate monitor, we saw the same thing. So we know, again, this can increase cognitive workload. It's the curriculum that we build to make sure that we can do that for individual squad leaders, I think is the important thing. So I think that we're going to get pretty positive results as we continue to look through the data and everything over the next few months and actually write the thesis. That we're going to get these positive results that we want, because when I was a platoon commander, a lot of the Marines saw this as the DVTE stuff, the TDK stuff, a lot of times as a waste of time. It was very forced. It worked really well when we had Bohemia developers there and when we had 2MEF Sim Center support and ONR support. But when those guys left, again, a really powerful tool, really nice software, really nice hardware that the Marine Corps spends a lot of money on. And unfortunately, it ended up collecting dust and it ultimately got divested, which, you can argue how much it was used or not. But at the end of the day, it got divested. So looking at how well it can, again, train individual squad leaders, measure their cognitive workload, and help evaluate them. So going over some fallacies and realities that I'll get to in a second, that were kind of three main ones, because as I went through and, I thought, oh man, these guys aren't going to like this. They're going to think this is just as dumb as when I came, as when all these other guys were coming down and we were getting pushed through this stuff, as much as a purpose as it seems. And I remember one of the first guys looked up and he looks at me, he goes, hey, are these results going to be pushed up to the battalion commander? And I go, oh no, the IRB process is very strict. None of your PII is released, none of your evaluations. And he goes, no, I want the battalion commander to read what I'm writing and how I thought this system was, because I've never used this and it worked really well. We got 34 Marines to complete this experiment, and really notably, only 6 Marines ever leveraged or spoke to that squad systems operator. So we had guys there that said, hey, squad systems operator, what do you see on the ground? Can you move my UAS a little bit, a little bit farther south? Can what can you see there? Where are these guys at? And instead, that was really kind of unnatural for a lot of guys. And one of the injects in the script towards the end of the experiment was, hey, there's LAVs are reporting seeing movement about 500 meters south of your position. And guys would really struggle to, see that. And they weren't the ones controlling the UAS, but they could bring up the picture if they wanted to. It was the squad systems operator controlling UAS. So it was only a couple Marines that said, hey, squad systems operator, can you move this thing 500 meters south? And then they saw the enemy right away. So again, I definitely think that, this is a curriculum that we can use and can be implemented. So going over 3 fallacies that kind of really struck me as I went through. We constantly hear that these systems need to be fun. They need to get Marines to play this system. If we could only have Call of Duty, then it would be great. This generation grew up with computers, and these are second nature. These can be picked up with ease. And man-to-unmanned teaming is a trust problem. Again, here's me with one of my squad leaders. We're planning and in front of all these VBS3 computers. When we had Bohemia there, the developers worked really great. But again, so this fallacy number 1, these simulations need to be fun. I think that's a really, looking at it now, it's kind of an insult to the Marines. The Marines are professionals. If we want a more mature force, it's not about giving them Call of Duty and making sure that they can, just have Call of Duty tournaments all day. We need to, and we owe it to them. Again, our bread and butter, the thing that makes up 64% of our force, our E3s through E6, Lance Corporal through Staff Sergeant. We owe them better simulations. We owe Marine Corps infantry squads better, and frankly, we try and cut quarters and we try and cut costs, but this is where we need to really pay attention. One of the Marines said, I wish we could use this more. He wrote this down. He said, I haven't done any simulation in months, and this prac app was a great refresher and experience. And that's really in par with what a lot of the Marines were saying. We constantly say, oh, we need these simulations to be much more higher fidelity. We need them to look and feel, as realistic as possible. In the reality of it is, Marines want to train. And the difference is the infantry Marines interface is with the real world. So it's really hard to get high fidelity with VBS3 or now VBS4. But one of the things I think we saw too is when we add this radio component, the interface is no longer the real world. So it's not so hard. We don't have to make it so hard to replicate the real world where we're never, or, in the near future, we're not going to be able to do that. However, with that radio, that gives us an interface for them to use. So I think that's something to think about. And then also VBS has so many capabilities, uses so much computing power. But the thing at the end of the day is we never intended in this scenario, in this curriculum, to use the scope, to use it as a first-person shooter. If we want to train marksmanship, the ISMIT does that. We have the indoor, simulated marksmanship trainer. But VBS shouldn't be doing that. Fallacy number 2, computers are second nature. One Marine came in, he was a cattle rancher, he was EASing, he was going back to his ranch, and they're not even that familiar with these ASDW controls of gaming controls. A lot of them complain about all the buttonology. But at the same time, I think we owe it to them to just give them more training, give them the training course. Just like when I got to the fleet, we go, they send platoon commanders to a small unit level training course, and we get trained on the other Marine Corps systems like McTims. Again, one of the Marines, I wish I had this training for my younger Marines, and we could use this system as an entire squad and not just one Marine at a time. So these guys liked it. They hadn't seen VBS3 before. A lot of them had not. And lastly, it's about trust and trust issues. I think this is a fallacy because right now we're looking at all this autonomous, semi-autonomous systems as Marines don't trust them. At the end of the day, Marines need training. We, again, owe it to them. We talk about trusting our gear in the Marine Corps and how, we go to the gas chamber to train for better trust with our gas masks and things like that. We owe them the training. One of the Marines, our battalion needs to educate us in these systems so that we can utilize them more and improve our performance. Again, the Marines had never seen their DVTE suite that was owned by 2nd LAR, and it was all set up. And we need to have, we owe them a little bit better training to get them more fidelity for using the squad systems operator concept. I don't think it was because they don't trust the UAS or the UAS picture or their squad systems operator. I think it's because they didn't know how to use it. And really the Marines that knew how to use it best were the very few that were sent to UAS operator school or were JFO qualified and kind of knew how to use it. So some of the recommendations that I'm, kind of contemplating is we need to create a curriculum for DVT training. Right now, it really seems like it's on the 4 contractors that work up at the MEF level. I think that there needs to be a class that you could send NCOs to bring that knowledge back to the individual unit. Increase interconnectivity and fidelity for the radio interface components. Again, the infantryman interfaces with the radio, just like a helicopter pilot. We have great helicopter and flight simulators. It's because their interface is all those controls right in front of them, and obviously we can simulate the screen. UAS operators and JFOs and leaders need to develop better standardized reporting procedures. We have all these reporting procedures for CASEVAC and SITREPs and all these other things. And that's a big one, I think, that came out of this one. And then as well, increase the accessibility to the DVTE systems. Right now, it's in a weird place because you have a lot of expensive computers. How do you keep them locked up and accountable? My advisors are Dr. Below, Dr. Molly McGuire, and Mr. Chris Fitzpatrick. And I'm sorry I went a little bit long, but I'll take any questions at this time.
No problem at all with the length, Max. That was really great. Thanks a lot. Appreciate that. So does anybody have any questions for Max?
Hey, Max, Charlie Rowan. Appreciate that brief. That was excellent. Wondering with the trust component, I was thinking about that. Did you get any feedback from the Marines about trust specifically? I guess we could look at it, the more that they are, it sounds like a lot of them are familiar with the system, and maybe the more that they're familiar with, the more they train on it, that builds trust, and that could be a good thing. But did anybody overtly just say, like, I had a hard time, like, delegating some of this stuff or, like, believing in the things I was using? Expressly, did they say that?
So the reason I talk about trust is because this is such a hot topic. You know, I'm seeing, you know, we're seeing so many theses right now about trust and how we build trust with these systems and all that stuff, and how do people increase trust. And to me, what I found was really trying to leverage the squad systems operator concept. It's really novel. Again, Lieutenant Colonel Cuomo, who is the battalion commander for 2nd LAR, when I was talking to him about this, he came up with this thing because he acknowledged that the workload capacity for the squad leader, for the infantry squad leader, is really being overstretched. So they increased, you know, his assistant within the squad as the squad systems operator. To get to your question, nobody said, I don't trust the picture that I'm seeing. Instead, I think we saw the opposite, which is the first thing that cued me on this. They really, for the first time, guys were seeing the fidelity and ability of the UAS, right? They were able to see that picture that the UAS was presenting, and I think they couldn't believe how well we used the IR pictures, the IR gimbal for a Raven within the simulation. And I think they were really shocked because a lot of them hadn't seen it. In LAR, which is a reconnaissance unit, they even said their comments about UAS was, oh, you know, we're always on the move, and there's a lot of hesitancy to get UAS up in the air. And so that's what really cued me off, is they really liked and they really commented about how high fidelity the picture was. And so what made me think was, okay, so they trust what they're seeing and they're looking at it, but they don't know how to use the squad systems operator. And so that's the gap there, I think. I don't think it's a problem so much trust in the system. And I think, you know, maybe I'm overextending what my results were from the experiment versus what I'm kind of seeing as a fallacy in the big picture of things. But just my reaction immediately was, wow, this isn't so much about how much these guys trust or distrust the system. It's how well they're able to use, the system. You know, we again, we're kind of saying trust or don't trust based on just throwing this stuff at them, you know, giving them this gear, and then we run an experiment and we say, oh, you know, I guess they don't trust as much as we thought they would. But we're not taking them to the gas chamber. We're not gassing these guys. We're not giving them that opportunity to use it. I think there's been very few opportunities for Marines to have a squad systems operator and a UAS operator in the field and say, here's what I'm seeing. And it goes back as well. I had Lieutenant Colonel Mines, who built this TDK system in Jordan. He ringed, we were doing platoon ranges in Jordan, and, you know, you go over the hill and that's kind of when the platoon range starts. And obviously it's just targets that are sitting out there. And the first guy who went through, Lieutenant Colonel Mines, reamed this guy because he didn't use UAS. We have UAS operators in the platoon, and obviously it's sort of make believe. You know the targets that are over there. We've done the range walk, but he wanted to make sure that the lieutenants knew to put the UAS over there, see what's going on, and then go attack it. And I think that's really important. And it was just it's a muscle movement that we don't do and we don't acknowledge as far as all of this unmanned system stuff. I don't know if that answers your question. The only thing that the guys talked about with trust was that they really couldn't believe how much they were willing to trust the system. And in fact, that part of it almost gave them tunnel vision into trying to look at and, you know, grab that thing from the squad systems operator and look at it, even though they were never controlling it. They could see the picture if they wanted to, but, you know, it was like in real life, they could look at the picture if they wanted, but they could never control it and send it wherever. If they wanted to control it, they had to say, hey, move it 500 meters west or whatever they wanted. So it was a really just interesting outcome that I wasn't expecting from what I saw.
No, yeah, that's perfect. I appreciate it. And I think, you know, the more that they train, the more exposed to it, because it seems like even there, you know, I'll be curious what your final write-up is going to be, but they were looking for something to maybe subconsciously even to take away that workload from them. And so that's why they were taking the peek and looking at it more. And that probably helped their performance and say, oh, this is this thing that can help me perform if I take it away from me and I have a more complete picture with the system. So that's interesting stuff. Thank you.
Yeah, absolutely.
Excellent. Does anyone else have any questions?
Hey, Max, this is Neil Fitzpatrick. Is my audio okay?
I could hear you just fine.
Great. Okay. So I'm an old move student in many ways. But back in 2008, I did a short mission to Iraq out of 29 Palms. And I took a DVTE suite over there and we set it up at a range. You mentioned something about the accessibility of DVTE, and I have honestly lost track of a lot of those aspects of DVTE. Is it a rare thing, or do they have to go to the sim center, or do they have them in their units? How does that work now?
Yeah, so that's part of the problem, and one of the things that I really wanted to talk about. One of the pictures in the presentation is Sergeant Major Black, the current Sergeant Major of the Marine Corps, and I talking, and it's like, how can we get these guys interested in playing? So I think there's a few problems. One, when we had the TDK kits, those things cost a lot of money. They had really nice MSIs. They came with Xbox controllers. And one of the problems at the battalion level is the Xbox controllers keep walking off. They also had HoloLenses in them when HoloLenses were brand new. I mean, well, not brand new, but when 4 or 5 years ago, they had HoloLenses in them. So I think the first problem is, and this was something the Marines said as well, of the few Marines that knew about the DVTE, they go, this room is locked. I can't just come in here, bring the squads in here. I can't just bring my Marines in here and train. And it's the same thing with the barracks. Do we put DVTEs in the barracks? If we want guys to use this just like Call of Duty, then it needs to be that accessible, but we can't have this stuff walking off. So I think there's that first part. What you talked about was fantastic. We had the TDKs on my deployment as well. The idea is Marines are being put on ship, and what better way to run a rehearsal than go on the computers on ship and walk through it there. But again, what is the accessibility? If you've got to network all of these things through a router on ship, and that's going to take some time to all set up. Where do you set it up on ship? There's really not that many spaces, and you really have to prioritize and allocate spaces. So there's that as well. Accessibility in terms of networking. They've talked about networking the DVTEs and putting them online because that's been a pretty big barrier for quite some time. These things are all still Cat5 hardwired to a router, and they do not have any connectivity whatsoever. So could we increase connectivity by giving guys, the ability to put some of these things on their own personal computers and, practice even radio reporting? The fact that we had the CNR sim and it worked so well, guys at 2nd LAR loved that thing because they said even in the LAVs, they can't talk all that well that often. So being able to practice reporting, and there's just something different about having to click the button and send a radio transmission versus just turn to the guy next to you and obviously, read off your 9 lines. So at the end of the day, I think the number one accessibility problem, to answer your question, is most units do not have them. The DVTEs are kept either at the regimental or the MEF level. In 2 MEF, it's really at the MEF level is where their DVTE suite lies. They're no longer at the battalions. 2nd LAR has a DVTE suite, but they're one of the only ones. And then what was kind of replacing them was the TDK system, but that's all been divested, and most of the licenses on the VBS products in there are no longer good anyways. So it's kind of where it's accessibility in terms of right now it's all over the place. Battalions don't have them, or they pull them out once every 6 months for the inventory, or the VBS licenses are expiring and nobody cares to renew them. So to your point, it worked great for you. It worked great for you, 13, 14 years ago. But now, again, they're collecting dust. And my research is kind of saying, well, if we have a really good curriculum, these things don't need to collect dust. And so that's kind of what I mean when I say accessibility problems there's really accessibility problems all over. At the end of the day, how do you give, a really hard charging corporal who wants to take a squad in there, how do you give them the keys to this thing? And the next time you go in there, oh crap, there's, couple Xbox controllers or headsets missing or whatever else. So yeah.
I could tell you a story, and I will if you email me later, but this is something I'm really interested in. And it's something that Dr. Sadegich and I talked about many years ago. And it seems like some of these problems are still existing. So anyway, great answer. Thank you very much.
Yeah, thank you for your question, sir.
Okay, any others? Okay, well, thank you very much, Max. Really appreciate it. That was great. And that concludes today's. So we're done with today's. And again, please come back tomorrow. We'll be running at 0900. We only have 4 speakers, so we'll be done fairly quickly. And again, if you have any questions or comments about the open house or anything else, please don't hesitate to reach out to me. But thank you very much for everyone who's in here, and especially big thanks to all our speakers today. They all did a great job. Thank you. Bye.